This conference will now be recorded.
Well, since I hope everyone is here and we have a lot to cover, we really should begin today's virtual conference. I really appreciate you all for attending today's virtual conference. A very good morning, good afternoon, or good evening to everyone and all present here virtually with me today. Let me introduce myself. My name is Clara McBroom, Conference Secretariat at Coalesce Research Group LLC, and I will be available for any of your queries or questions throughout the webinar to help you out technically and organize the webinar successfully. For the next 5 minutes, please allow me to give a brief description about our organization, Coalesce Research Group, and also the further instructions. Coalesce Research Group LLC is very delighted to welcome you all, the speakers, supporting associations, students, and delegates present here virtually with us today. With the aim mark the scientific excellence by felicitation, conversation, sharing knowledge, Coalesce Research Group follows through the objective of setting standards in delivering excellence in the research among the researchers and industries, promulgating the research through conducting events and online webinars from various fields of science, especially from the stream of medicine, science, and engineering and technology. As a global scientific event organizer, we plan and carry out international conference, meetings, seminars, symposium, and workshops, providing the best delegate experience, excellent networking opportunities, conversation leading to innovations, learning new opportunities. Just recently, we have also coined up and started our own platform for open access peer-reviewed scholarly literature where all the content is freely available without any charge to the reader. As being very new to journals, we have coined up some interesting journals and have also formed the editorial board, and we will be very glad if you any of today's attendees, the speakers, students, or delegates could extend your support by checking the journals and will be interested in publishing an inaugural issue at any of the journal according to the area of expertise. We will also send an email with all the details about the journal after the webinar. Do take time to check the website. Thank you. And now, finally, I would like to thank all the attendees and participants of today's virtual conference on Third International Conference on Applied Science and Engineering, and hope you enjoy the webinar and gain knowledge from the sessions today. We also hope your participation will contribute to new research findings and that will lead to new collaborations and research initiatives. Before we start with the session, I guess some of you will be new to GoToMeetings app. Let me just explain you the important tools required for the presentation. On the GoToMeetings app or a web page, you can find four icons at the bottom center: mic, camera, screen, and end button. The mic button, click on that to mute or unmute yourself. I request you all to stay muted while our speakers are presenting their research work so that it does not get disturbance to them. Camera button, you can use this button to share or unshare the web camera. If you have the option to share the web camera, you can do it and it's completely your choice. For screen button, you can use this button to share your screen. This is the main part during your presentation. After I call your name from my side, I will be making you as a presenter and will give the permission to share your screen. Then only you will be able to share your screen. So once I make you as a presenter, you can click on the screen button and you will find a pop-up window to share your screen. During the screen sharing, kindly click on complete screen sharing. And the last icon is end button. This is your fourth icon where you can use this to leave the session. On the top center, you can use this option to change your display settings. At the top right corner, you will have three icons: people, chat, and settings. In the chat option, you can chat with me or with any other participants. For the settings, you can use this button to check for the settings of your speakers and microphone. So as I mentioned, kindly remain muted during the presentation so that the presenters don't get disturbed. And for any questions, you can ask the questions or you can send your questions in the message box too. Well, let's not take much of your time. Finally, I would like to request you to please give us a brief introduction about yourself before starting with the session so that we can know about you virtually. And now let's move on to the our session. The first presenter is Dr. Roberto Espinosa from Fulton Hongan Private Limited, Australia. Hello, Dr. Roberto. Are you ready with the presentation? Hello, Dr. Roberto. Are you ready with your presentation? Can you please unmute yourself?
Yes. Hey, yes,
Okay,
I'm ready. Thank you. Yep.
okay. Now I'm making as a presenter. Kindly click on the screen button to share your screen, please.
Yep. Wait. Yep, it's sharing, is it?
No, it is not shared it.
Can you see this?
Yes, your screen is shared. Yes, it's perfect.
So
You can
am
start your
I
presentation.
okay? All right. Good morning, good afternoon, everyone. Welcome to my presentation. First of all, let me thank you for coming here today, and let me start by saying a few words about myself. So my name is Roberto Espinosa. I am from Brisbane, Australia, and I'm originally from the Philippines. I am a technical engineer here at our company at Fulton Hogan. It is a construction company that also produces different varieties of construction products, such as concrete, variety of asphalts, and aggregates. So I manage our research and development laboratory, and together with the technical team, I design asphalt mixes and foam bitumen base for the whole state of Queensland. So my co-authors for this study, my co-author is Dr. Laszlo Peto, which is not here with us today, but I will be presenting this myself. As you can see on your screen, our topic is about foam bitumen stabilization, particularly the effects of delayed compaction to the resilient modules of foam bitumen stabilized materials. Now, this presentation is particularly relevant to those of you who are in paving construction using stabilized materials. Now, this talk is designed as a review on the working time or shelf life of foam bitumen-based materials through laboratories in Queensland, for example. Current specification only allows 5 hours of stockpile time and 3 hours of construction time, which gives a total of 8 hours of working time, which is for most of us a very short time. Now, this morning, afternoon, or evening, I'm going to discuss my findings and the possibility of extending the working time of foam bitumen-based materials. So this project is actually in collaboration with with our um, industrial leaders, in particularly the Department of Main Roads of Queensland. Now, for this presentation, it will be presented first as a background to those who heard of haven't been exposed to foam bitumen stabilized materials. I will give you a very brief background, and after that I'm gonna tell you the objectives and limitations of my study, a bit of an introduction, and then the methods of research that we did and the results, and finally the conclusions. Now, if you have any questions, I'm happy to answer them, but unfortunately, I couldn't see it in my screen. So it's just my screen is the PowerPoint. Yeah. Now, well, I can answer it at the end. All right. first of all, let me introduce to you what is foam bitumen stabilization. So, since 1997 in Queensland, Australia, main roads, the department has been trialing foam bitumen stabilization as a potential structural rehabilitation treatment for roads in Queensland. And it is a stabilization is considered to be more flexible than other stabilization treatments such as cement-treated base or hydrated lime base. And lastly, it's also aimed to treat. This treatment is to achieve a more flexible but strong and impermeable road pavement. So later on, I will explain to you why this foam bitumen base is more resilient to flooding or to intrusion of waters, just because of its properties. Now, for those of you who are not familiar with foam bitumen base, FBB is actually just a blend of gravel, hydrated lime, which is our um, secondary agent. Some uses cement, and our and then the foam bitumen. This is just a foam bitumen, an actual bitumen with water, and then finally we have what we call the construction water. So the construction water will help the compaction of our stabilized materials. Now, foam bitumen is the product of a stabilization technique using foam bitumen as the primary binder and lime in this study as the secondary binder. It is a moisture-resistant flexible pavement material for use as base or sub-base in pavements, and also it improves the strength or modulus and reduces the moisture sensitivity characteristics of the unbound granular materials. Now, this is what the foam bitumen looks like. Now, when the water, so in the plant, we have injection of water and air and also the hot bitumen. So that the moment the water turns into touches the hot bitumen, it turns into steam, and then it becomes encapsulated by the viscous bitumen, thus producing foam. Now that at this stage is the perfect time when this foam bitumen is used to stabilize our unbound materials. Now we just don't do any foam. So the foam has to have a certain quality or a certain characteristics. Now there are two ways to characterize the foam bitumen. Number one is through the expansion ratio and through a half-life. So expansion ratio is simply the ratio between the maximum volume that the foam achieved at its and then divided by the final volume and at the very end of the test. So this is the time when the foam collapses. So this is what a foam bitumen looks like. So that now at this stage it has reached its maximum height until it began so you see it starting to subside. So the final volume at the very end, it goes down, that's our final volume. So that's the expansion ratio. The second property of a good quality foam is to check the quality of the foam is what we call the half-life. Now the half-life that is just the time, that is in seconds, between the moment the foam achieves its maximum volume and the time it subsides to half of its volume. So, for example, in this case, it has achieved a total of 24 times expansion ratio. From that time on, when it starts to subside to up to 12 times its expansion ratio, that time is what we call the half-life, the time that achieves, which in most specification is only 10 seconds. Now, if we look at the foam bitumen base in a microscope, so it will look like this. So we get what we call the skeleton, the aggregate skeleton, which composed of the bigger fractions of our unbound material, and then that foam bitumen together with the very fine materials, which we call the filler, now becomes the asphalt mastic droplet, and that millions of individual elastic points becomes the like the spot weld, which non-continuously bound all the entire structure of the foam bitumen base. Now, because of this, the fine particles now becomes immobilized. Thus, even if the water comes in, it is still it couldn't be removed because it has already become part of the asphalt mastic droplets. And those finer materials will just fill some of the voids, which what we call the mineral filler phase. Now this is what it looks like in a microscope. So all of these black points here, so these are what we call the asphalt mastic droplets. We have millions of these that non-continuously bound our entire material. Now that we know a little bit about foam bitumen structure, foam bitumen characterization, now it's time for me to explain to you why I do this research. The objectives of this research, number one, is to investigate the impacts of delayed laboratory compaction to the resilient modulus of foam bitumen stabilized base. Now, because currently the specification requires us to finish the compaction after stabilization within 75 minutes. Another objective is to determine the maximum stockpile time of foam bitumen base, which I mentioned earlier, is only 5 hours at this stage in the current specification. And finally, the third objective of this research is to compare the resilient modulus of the experimental sample against our local standard specification. Then we can compare the difference. Now, but this study is not perfect. We have, as most studies, you have some limitations, which includes for this study we only use a single road-based material, so it doesn't cover most of the different types of road-based materials in Australia. It's just one road-based material which we usually use, and and then the mean results, as you can see in my results, are all only the average of 3 specimens, which is what is required in our test methods, an average of 3. And finally, the findings does not apply to FBB using cement as the secondary binder. So that in this case, the secondary binder was the hydrated lime. So we get a primary binder, which is the foam bitumen, and the secondary binder, which is the hydrated lime. Now, why bother? Why would I have to do these results? I mean, this is an investigation. Most importantly, number one is foam bitumen is becoming mainstream in regional areas of Australia. If you could imagine, Australia is a massive continent with a big land, desert in the middle, and then the transporting good quality materials is a challenge. Now, why can't we just instead of sending all the testings to external laboratories, the intention is for the local laboratories in the middle of the desert can perform their tests or can send samples to other areas in the main cities. Another objective, of course, is that because some regional laboratories are not equipped with the required sophisticated testing equipment, which are costly to acquire and to maintain, the big challenge. Another challenge is specimens for resilient modulus must be compacted within 75 minutes after stabilization. That is the current testing method and specification, which in some areas it is just impossible to achieve. So resilient modulus for foam bitumen stabilization, it is the most important characteristics of an FBB. It's very critical. That is why in this research, I'd like to point out that we could actually extend the shelf life of FBB more than 75 hours. 75 minutes, I mean. Now the methods. So in this particular research, we have the method having 3% of bitumen content, that's the mixed design, with 1.5% hydrated lime. And we have to add a foaming agent just to help the foam, which is 0.5%. And the ratio, or what we call the target moisture ratio, is 70%. So this is the amount of water that we have to add into our material as a percentage of the maximum of the optimum moisture content of the materials. Now, based on our specification, this is the grading envelope of the material I'm using. Now, this is what the foam bitumen specimen looks like at certain stages. Firstly, we've got this is how it looks like after compaction. I can actually barely see any asphalt binder here. because it's minute, it's very microscopic. It's 150 millimeter in diameter, and then after compaction, we put them in the oven to cure at a low temperature oven, which is 40 degrees centigrade. And in some tests, we cure them for 3 days, 7 days, and 14 days. Now, at the very end of the test, we have to dry that specimen into a drying oven, which is 110 degrees centigrade. And this is what it looks like. Now, there you can see that the binder, the asphalt, just here. So these are now, because we dried out all the moistures. Now, this is the compaction hammer that we used for this test, which is around 10.8 kilos weight. And also, yeah. Now, as I mentioned earlier, solid modulus is the most important characteristic of a foam bitumen. What we do is we have one sample, we test them for cured modulus. Now, that same sample, we partially saturate it for 10 minutes in a vacuum chamber with water for 10 minutes. And then the ratio between the soft modulus and the cured modulus is what we call the retained modulus, which is again is an important factor to identify the quality of the foam bitumen. During saturation, this is what it looks like. So that's the vacuum chamber, and then I'm gonna apply a pressure that is minus 88 kPa, and then for 10 minutes it's hoping it will absorb all the moisture. And that same sample after saturation will be tested again for silent modulus using the same machine. What we do is we put a mark here so that when after it's being saturated, we will test it at the same spot that the specimen was tested when it was dry, or what we call the cured. So the cured and the soft modulus are of the same age, either 3 days, 7 days, or 14 days. Now for this experiment, I did three sets. So we've got 3 sets of experiments. We've got this experiment 1, 2, and 3. The first experiment, what I did was the delay was 24 hours, 48 hours, and 72 hours. And then so we got 1 day, 2 days, and 3 days. The variables at this stage is just the time between stabilization and compaction. So you've got the control and the experimental samples. The control that it was compacted within 75 minutes after stabilization, because that's what the test method says and most of our specifications. Now the experimental samples, they were delayed for 1 day, 2 days, or 3 days. So the variable now is the time, the delay of the compaction. The constants are the materials, the same identical samples, curing and testing, same tested on the same day, age, and then the same stuff that did all the tests. In the second experiment, we waited until 4 days. So the delay is now again 4 days with the same variable and constants. The constant being the identical subsamples. We get the testing days and the testing stuff. The third day, we waited until 7 days. So again, the control was performed within 75 minutes after stabilization, and then the experimental sample was delayed for 7 days. So how do we delay the samples? We put them into a sealed watertight container, and then we leave them until they are ready for compaction. Now these are the results. Now so that we've got here the method, the experiments that I did, and the time delay, the cure delays, and the results. Now the time delay, that is just the time between stabilization and compaction. So that's the time. For example, this stage, for example, in this case, we delayed this. Our experimental samples were delayed for 1 day. Experimental samples were delayed for 2 days, 3 days, 4 days, and 7 days. Now, curing time. The curing time, that is the time between compaction and then into the oven and then testing. So after compaction, we put that in the oven. That starts the curing time. This is the curing oven at low heat temperature, 40 degrees Celsius. And then we leave it there for example, for 5 days, 3 days, and 7 days. And then we test it for restaurant modulus. The time between after compaction into the oven and out of the oven to the testing machine, that is the cured time. Now, in these experiments, we have 5 days, 3 days, 7 and 14 days, 3 days, 7 and 10 days. So now the reason we have 5 days or 10 days here, normally we test them at 3 days, 7 days, and 14 days. But sometimes the experiment, because of holidays and unforeseen events, we have to start the test up before schedule. So that's why we have 10 days here delay. But it doesn't matter because the control and experimental specimen were tested on the same day. I mean, on the same amount of curing days. Now, these are the results. For example, everything in yellow, this was my control, and this is the experiment. And we get here, I just see the very end, the very last column is the variation in percent. And here is the graph that shows the results, the data on the left side. Now, in this graph, it's very easy to see that this is what they call the unity line. Now, this unity line, the more all the data in the line, it means they have the same results. The x-axis being the control, the recurrent modulus of the control specimens, and the y-axis being the recurrent modulus of the experimental specimens. Now, so as you can see here, the specimens delayed for 1 day, 2 days, and 3 days. They are here around just above the unity line, which means they're actually significantly, they are just a little bit higher than the control. And then if the number of delays increases to 4 days up to 7 days, we can see that then it starts to show the difference, the variation. Now, in FBB, the most important recurrent modulus that we look at is what we call the soak modulus. This is after subjecting the specimens into a saturation. But as you can see here on the first 2 and 3 days, there's barely a significant difference. And we're talking of days. We're talking about 24 hours, 48 hours, 72 hours. And that is the delay that compared to the current specification of 8 hours only. So see, and then at 4 days delay, it's still good test, and then it's still significant. But at 14 days curing, there's a bit of the difference there, but not significant. But in 7 days, you can see there's a big, the experimental sample is just very low compared to our controls. And then another parameter is what I call the retained modulus. As you can see here, the control retained modulus and the experimental modulus here, there's a bit of a variation, but most importantly, all of these results here in the experimental experiments, they are all above the industry standards, which is still acceptable in some degree. Now, in Queensland, our standard specification is called MRTS 09. So comparing our results, the results of my experiments against our standard specification, as you can see here, the limits in red at 3 days, at 7 days, and 14 days curing, all of my experiments up to 7 days there is still above the standard specification. Same thing with the resilient modulus. The standard specification minimum is 40.45 or 45%, and all the results I got are all above the industrial limits, regardless if it performs better or if it underperforms compared to the standard or the control specimens. Now, as a conclusion, we could say that test results show that the delay in laboratory compaction of up to 4 days has no detrimental effect to the soft modulus of FBB specimen compared to the control group. And then the extended compaction delay would allow enough time to send samples from site to an external laboratory located in a central location for compaction and testing. So this is actually the main intention of this investigation. It's because to give an allowance for projects in regional areas to send their samples to a laboratory in the city with a delay, potential delays of up to 7 days. Now we know that it actually could still perform similarly or even better compared to a control group. And lastly, after 7 days of delayed compaction, although the result FBB can still perform above specification, although results are highly lower compared to the control group, regardless, compared to the standard specification, it is still acceptable. Now, these are the three main points I'd like to, is the takeaway of this investigation. Now, these are just some of the projects we performed here in Queensland with an FBB. So this is what an FBB looked like before compaction. So it's dark. It's not as this is very much similar, very much a road-based material, if we know what a road base is. And yes, that's the end of my presentation. Thank you so much for listening.
Thank you, Dr. Roberto, for your presence and presentation. Does anyone having any queries? Please, once again, thank you, Doctor, for your presence and presentation.
Thank you. Yeah, you're welcome. Thank you all for listening. Just any questions? Yep, you can just send me an email. I think yeah, you can contact the organizers. I have my contact details to them.
Sure, Dr. Roberto. Now let's move on to the next presentation from Dr. George Fellmenden from OWL University of Applied Science and Arts, Germany. Hello, Dr. George. Are you ready with your presentation?
Hello everybody, can you hear me?
Yeah, you're audible, Doctor. Now I'm making you as a presenter. Kindly click on the screen button to share your screen, please.
Yeah, but just to mention on the program, I'm the third one, not the second one. So I don't know if
Due
you
to
changed
some
that.
personal issue,
No
the
problem.
Dr. Ahmed has been dropped down from today's conference. He'll be joining tomorrow. Now, so to continue the program, we have announced the next name, which is you. So now,
Ah,
are you ready with your presentation now?
yes.
Okay.
Just a minute.
Sorry for the last intimation.
So, so you can see my slides?
Yeah, your screen is visible. You can start your presentation now.
Okay, just a second. I have to organize my screens. Okay, so thank you very much, ladies and gentlemen. Today, as you can see, I'm going to talk about our new project, which is called Water Plus OWL. OWL stands for a rural region in Germany. It's Ostwestfalia-Lippe. And regarding this, I'm going to talk about sector coupling and water infrastructure systems. So to give you a short overview about the content, I'm going to introduce the status quo of our water infrastructure systems, and then I'm describing the challenges that these systems or the operators of these systems are facing in the recent years, and which lead to the development of so-called resource-oriented water infrastructure systems. And then I'm going to move on to introduce sector coupling as a systematic research approach. and give some examples to show the potentials, but also the challenges of these kind of sector coupling, and yeah, some words about our new project, Water plus OVL, which deals with sector coupling at least. Oh, I'm sorry. Yeah, so I don't know how much you know about water infrastructure systems, but if you look in Germany as these water supply and wastewater disposal systems, we have achieved a high hygiene and environmental standard in Germany over the last 150 years. So the main tasks are drinking and surface water supply, of course, and to deal with the wastewater on the other side. And yeah, if you look from a perspective of today to the status quo of these kind of infrastructure systems, so that means pipes and treatment plants at least. Yeah, these big systems remain very inflexible and have a low resource efficiency, with, on the other hand, relatively high investment and operational costs. So on the right side, you can see a picture that is just one possibility to show these characteristics of the systems. Yeah, and on the left side you have some bullet points to the status quo. One reason for this disadvantages of the system is that we use only one water quality to serve all purposes. So we use drinking water quality, the highest standard of water, and we use it for, of course, drinking and cooking, but also for taking a shower and at least for flushing the toilets. So, and we have, because of the system, the design of the system, we have a high drinking water demand. Doesn't matter what the people are using, you know, how much or how less water, but the system itself has a high drinking water demand because it's only drinking water. So if you see this, you can of course ask if these water infrastructure systems, from a perspective from today, are sustainable or not. And this becomes even more clearer when looking at the challenges these infrastructures or the operators of the infrastructures are increasingly facing. And I think you know one of these or some of these, of course, the climate and demographic change, as you can see here, and the negative impacts on the water systems, like increasing drinking and irrigation water demand, and when it comes to heavy stormwater events, and in addition afterwards to some dry periods of several weeks or months, we have to deal in a different way with rainwater and advanced rainwater management. Demographic change, of course, if there is a city or a region where a lot of people move on or move in and settle down, we have an overload of the system. And on the other side, where people are leaving a region, we have an underutilization of the pipes and the treatment plants, which causes several problems. So that is about the movement of people, but as you know, people, generally speaking, will get more older in the future. So that means that they are also using more pharmaceuticals, and we have more pharmaceuticals and wastewater in the future because older people normally use more of these kinds of pharmaceuticals. And in addition to demographic and climate change, we have other challenges or drivers like environmental requirements. For example, the sewage sludge ordinance in Germany, which was which go into practice in 2017. So it's 6 years ago, and we have to reorganize our whole way of dealing with the sewage sludge and using it. And that is a lot of changing in this field. And at the end, of course, we have different sustainability strategies like the SDGs, the Sustainable Development Goals on a global level, but also in Germany we have sustainability strategies. That means even if we have this high standard of water supply and wastewater disposal, we have to increase our efficient use of water and energy and nutrients which are inside the water and the wastewater. So there are many different drivers to think about to transform our central grid-bound systems of water supply and wastewater disposal. And how to react on these challenges? In the last recent years, we developed not only in Germany but in other countries as well the so-called oriented water infrastructure, resource-oriented water infrastructure systems. And these systems show characteristics like separated collection and treatment of wastewater streams. For example, we divide gray water and black water, as you can see on the right side down there. You see here gray water, and which means that is the wastewater from the households without wastewater from toilets, and the black water is the wastewater from the toilet. So we can divide it at least into two different streams, but even the black water we can divide in the feces and urine stream if we want to. So it gets really more complicated, but these novel systems aim to close the loops by reusing the water itself, the energy inside the water, for example the heat, and the nutrients like phosphorus and the nitrogen. And hopefully we can create cost-efficient alternatives to the current system, the central system, which only consists of one pipe to the households with drinking water and at least one pipe out of the houses with the wastewater. So closing the loops, as I mentioned, if you want to reuse the water or the heat, then we have to consider other sectors in addition to the water or wastewater sector. So that means we have to define different sectors, and we have to combine these resources and the technical systems. And of course, if you look at the energy system, we have at least three different sectors: the electricity sector, the heat supply sector, and the cold supply sector, which gets more important year by year due to climate change. Then we have, of course, from my perspective, the water supply and the wastewater sector, and which is interesting that you can divide different sectors within an area like energy and water. And in addition, we have the waste management sector, and of course the sector dealing with roads and bridges and so on, so the traffic sector. We call this kind of sectors the so-called technical infrastructure. So it consists a lot of nets and treatment plants and so on. And in addition to that, I don't know if you have heard about the green and blue infrastructure. We can, if you are in a city and you have single trees and a park and so on, and flowers, you can look at these different plants in a single way, or you can look at them in a combined way, which means that you realize that this is also a network, so it's a combined infrastructure. So all these greens are called green infrastructure, and of course if you have ponds and lakes and rivers and so on, you have the so-called blue infrastructure. So not looking only at one pond in the city, but all of the blue infrastructure components. And we call this infrastructure near nature infrastructure, let's say. And at least we can also think about the buildings and the surface area of the yard surface behind the buildings and so on. So we call it the social infrastructure, which means that we are not talking about how many schools we have in a city, but we are using and thinking about the buildings and the surface area of these social infrastructure, because we can use it to deal in another way with water and wastewater. So we have this 3 different, let's say, infrastructure areas and different sectors in between. So in order to understand wastewater and water as a resource, and in the last 10-15 years there was a certain development regarding this, and we had some pilot projects where, for example, water is reused or the nutrients, but there is not really an implementation in a big scale in one country. So in order to increase the number of implementations of these resource-oriented infrastructure systems, I want to introduce a new systematic approach. And that means we put wastewater in the center. Yeah? And when we put wastewater in the center of our perspective, of course, as you can see on the right side, we have wastewater in the center. And then, of course, if I use the water of a treated wastewater to supply, for example, the irrigation of a garden, then I have a one-to-one coupling, let's say, from the wastewater to the water supply sector, as you can see here. But there are not only one-to-one couplings, but also multiple combinations of different sectors. And that makes it even more clearer what kind of or how many potentials we have regarding the sector coupling and the wastewater. For example, if you use a wastewater stream, let's say treated rainwater, to irrigate green roofs on the buildings, because in the dry periods the green roofs are not green anymore, they get brown, let's say, they are dried up and they cannot function as they should. So when we talk about green roofs, we have always to consider the irrigation part of these roofs. So if you use rainwater or treated wastewater to irrigate these green roofs on the buildings, you have a coupling from the wastewater sector with the green infrastructure sector at first, of course. Then we have a connection or a coupling with social infrastructure, that means with the buildings. And depending on the season, with a heat supply or cold supply because of the green roof on top of the houses. And all these kind of different couplings especially belong to spatial planning. So that means we have also a strong relationship to city planning if you look on different districts or the whole city or county. And of course, we have a combination to the water supply sector, as we saw it in the first coupling. So here you have another slide just to show the systematic of these sector coupling systems. So on the left hand, you have the different sectors like electricity, heat, cold, and here is wastewater. So for example, you have different levels of coupling. So if you store treated wastewater inside the blue infrastructure, so you have an artificial pond, let's say. So when there is a rain event, you can use this as a first coupling. Here you have the rainwater, and here you have the retention in the blue infrastructure. And then you use this water in the dry period for irrigating the green infrastructure, maybe a park or a green roof. You have a second coupling, and then this causes evaporating cooling. So that means you have in the area around this green infrastructure. So that means you have a connection, a third coupling to the cold supply of this area. And we do not have only these kind of different couplings, we have also some so-called additional or side effects. That means, for example, if you have a pond and you store water there, you have an increase of biodiversity. And for example, if you have more green areas, green roofs, which you irrigate with the rainwater, you have also a noise reduction around these houses, for example, increase of biodiversity, but also a reduction of fine particulate matter. So that means if you look from a systemic perspective on this, you can realize how many potentials this sector coupling has. Yeah, and just to show one possible example, I just want to introduce one of our previous research project, which was called Networks 3. So you can see there were 2 other projects before, and my colleagues are running, I think, the 5th project now. And it was about implementation, because we wanted to go into practice with these kind of systematic approach and sector coupling. So we, together with the Municipal Housing Association of the city of Frankfurt in Germany, we implemented a gray water and black water system, so a separated wastewater system in a passive house, as you can see on the picture here. There were 66 apartments, and there was also a daycare center at the basement. And the house was divided into 2 parts, let's say. On the right part, as you can see here, we divided the wastewater into 2 streams. So it was black water, the toilet wastewater, and the gray water, the leftover. So gray water is the wastewater from hand wash basin, from showers, from the laundry, and so on. So everything without toilet wastewater. On the other side of the building, we have a conventional wastewater discharge to the public sewer system, and then it went to the main treatment plant of Frankfurt. And yeah, inside the right building, regarding the gray water, we were treating the gray water on site in the basement and using the treated gray water for flushing the toilets on this side of the house. And because it was already separated from the other wastewater, also the heat was recovered and used for the drinking water system to heat up the drinking water. And this is especially interesting because the gray water has a higher temperature than the black water, the toilet flushing water. So we could implement this. It's still running. And here you see, I'm sorry for the German words, but I have no other sketch of that. You can see that in the basement we have these kind of black tanks. So there are 4 tanks. It's a biological treatment system, and it's really a closed system in the basement. And of course you need some space, but compared to this space, to the space of the whole building, it's not really relevant. So this is only one example where we have this combination, this sector coupling from wastewater to the water system because of the toilet flushing, and also from the wastewater to the heat supply system because we use the heat of the wastewater for heating up the drinking water, the warm water supply. Yeah, but there is always a but, of course, and as you can see here, we are facing different challenges. So we have, of course, further research on different levels. We have the technological level, and economical, and governance level, and also a conceptual level. And I don't want to go into too much details, but I want to emphasize on the 2 here in the middle, the economical level and the organizational level, because what we knew from our other research projects that are more technical is that, for example, for rainwater management, we know what we have to do, technically speaking. But in the reality, there are only a few pilot projects that were implemented. So we have a lack of implementation. And we were wondering why it is like this. And therefore, we created our new project, Water Plus OWL, because the integration of these kind of sector coupling into administrative action is not really taking place. So we want to overcome these hurdles, and therefore we submitted a project proposal, and we get funded by the Ministry of the country in North Rhine-Westphalia. And Water Plus OWO stands for Future Network for knowledge transfer in this region. So this is not really a technical project, and maybe this is really different from the other presentations today, because we want to emphasize on a governance aspects and to network and to come together to implement really innovative solutions in the water sector. So we bring together applied sciences, different disciplines, the practice people, the experts from the cities like the water and wastewater utilities, but also the society, and to transfer different knowledge in between these different partners. So this is as a project structure, as you may know from your own project, and I don't want to go to this into many details, but I want to emphasize on the working package 5, because we have a skills shortage in many disciplines, but especially in the water and wastewater sector. So in this project, we also want to take care about to require new engineers to study and to work in the water sector, because if we have a skills shortage in the water sector, that means that the running of the water supply for a whole city of 500,000 people is in danger. So that is something different if you have to wait for a product on the global market maybe 2 weeks longer. So I think the impact of skills shortage in water and wastewater sector is different to other sectors. So we have a starting network, our university, and we have the Ruhr University from Bochum, our colleague Martina Flörke, because as I mentioned at the beginning, OWL is a rural area. So we have in some cases the same challenges as an urban area, but we have also specific ones for the rural area. So therefore we have this interface to the urban area just to have an exchange on that side. And we have 6 cooperation partners, the city of Detmold, the counties around the city, and different municipal utilities just to start. And now we have 4 years to create a bigger network and to talk about these kind of challenges and to come together. And just to give you an idea, our next steps mainly is that we will have a joint workshop on of different municipal offices, because as you may also realize in your sector, that these different municipal offices have not so much connection to each other. So we want to talk about integrated rainwater management, because we have less implementation of these integrated systems, and therefore we want to bring together the wastewater and water utilities, the city planning department, of course, the parks department, civil engineering office, local water authorities, and so on. So we want to come together because they have to know each other, and and to talk, to implement, to think about these kind of combined systems, sector coupling systems. Yeah, thank you very much for your attention regarding the water news, let's say. And here are some informations about our department, Settlement Water Management at the university. And yeah, I'm now at your disposal for any questions. Thank you.
Thank you, Dr. Jones, for your presence and presentation. Does anyone having any queries? I hope there are no queries. Once again, thank you, Doctor, for your presence and presentation.
Okay, thanks a lot.
Thank you. Now let's move on to the next presentation from Dr. Marwa Khemis from Lames Laboratory University of 20 August 1955, Algeria. Hello, Dr. Marwa. Are you ready with the presentation?
Yes, yes.
Now, okay, thank you. Now I'm making you as a presenter. Kindly click on the screen button to share your screen, please.
Okay.
I have made you as a presenter. Have you received any pop-up window? Yes. Can you make it as a full screen mode and start your presentation now, please?
Is it visible?
Yeah, it is visible. You can start your presentation now.
Okay, thank you. Hello, everyone, and welcome to my presentation. I would like, first of all, to special thank the organizers of this conference for giving me this great opportunity to present my work. My name is Marwa Khemis. I am PhD student at 20 August 1955 Stigda University from Algeria. So today I'm going to give short presentation about positive periodic solutions of an iterative survival model of red blood cells. And I'm going to focus on four main sections. First, I will begin with an introduction. Then I will present some preliminaries needed in the sequel. The third section, in fact, is the core of my talk, where I will show you our main results. And finally, I will end this talk with a conclusion. So let me start by presenting our problem. The main objective behind this work is to establish the existence, uniqueness, and continuous dependence on parameters of positive periodic solutions for the following first-order differential equation with iterative terms given by expression 1, where a, b, and h are t-periodic functions with respect to the time variable. This term denotes the composition of x of t with itself. H is the harvesting function and tau is the harvest delay. Equation 1, which can describe the production of red blood cells in blood circulation of an animal, involves two types of delays, where the first one depends on both the time and the number of red blood cells, and the other one is a constant harvesting lag. More precisely, equation 1 can be considered as a special type of the following first-order differential equation, where x of t is the number of mature red blood cells in blood circulation at time t, A of t is the loss rate of red blood cells from the circulation. P of t is the production rate. This term stands for the flux of red blood cells in blood circulation, where tau1, which depends on both the time and the density of mature cells, describes the time delay between the production of immature cells in the bone marrow and their maturation for releasing in bloodstream. This depends on the density of mature cells, results from the fact that some growth factors and hormones control the division of the hematopoietic stem cells. Actually, when the number of mature blood cells is large, some growth factors and hormones suppress the division of the hematopoietic stem cells, and in the converse case, they will promote them. H, as I said at the beginning, denotes the harvesting term, and tau is the harvest lag. Let's turn now to the second section. So let's begin this section by defining a closed, convex, and bounded subset omega of the Banach space of all T-periodic continuous functions equipped with the usual supernorm norm. For simplifying our results, let's introduce these notations. Moreover, let's assume these assumptions to be true. The function h satisfies inequality 2, and these three inequalities hold. From lemma 1, we can point out that finding an antiperiodic solution of equation 1 is equivalent to finding an antiperiodic solution of this integral equation, where the obtained kernel is a Green's function and is given by this expression. It's worth mentioning that the obtained kernel satisfies properties 7 and 8. Let's now move on to the main results, and let me start by talking about the existence outcomes. So the main goal behind this section is to find some sufficient conditions that ensure the existence of at least one solution for equation 1, and for achieving this we will use a powerful technique based on the Schroeder's fixed point theorem combined with Green's functions method. For this, and by virtue of lemma 1, we define an integral operator A given by expression 9. It follows that x is solution of equation 1 if and only if x is fixed point of the operator A. For applying the Schroeder's fixed point theorem to prove the existence of at least one solution, it suffices to show that A is well defined, A is continuous and compact, and this inclusion is satisfied. By virtue of the periodic properties, lemma 2 clearly shows that A is well defined, while lemma 3 proves that it is continuous and compact operator. The proof of this last lemma is basically based on Ascoli-Arzelà theorem. So obviously the departure set omega is uniformly bounded and equicontinuous. Hence, as a consequence of Ascoli-Arzelà theorem, omega is relatively compact. And since it's closed, then omega is compact set. So to show that A is compact operator, it suffices to show that it is continuous. Indeed, for x and y in omega condition 2 and Green's function property 8 led to this estimate, which shows that A is Lipschitz operator and hence is continuous, so A is compact. The lemmas 4 and 5 under conditions 3 to 5 ensure the correctness of this inclusion, which means the operator A maps the departure set omega into itself. Now, and based on the previous lemmas, we state our first theorem, which establishes the existence of at least one solution. So it follows from the lemmas 2 to 5 that all conditions of the Schroeder's fixed point theorem are satisfied, so there exists at least one fixed point of the operator A, which is a positive periodic solution of equation 1. Moving on to the second part of this section, which discusses existence, uniqueness, and stability results. So for the existence and uniqueness results, in addition to the aforementioned conditions in theorem 1, suppose condition 10 is fulfilled, then equation 1 has a unique positive periodic solution that belongs to omega. Indeed, from lemma 3, for all x and y in omega, we get this estimate. From condition 10, A is a contraction, hence, as an outcome of the Banach contraction principle, A has a unique fixed point that belongs to omega, which is the unique solution of equation 1. Here is our last theorem, which establishes the continuous dependence of the unique solution. So under assumptions made in theorem 2, the unique solution obtained of equation 1 depends continuously on parameters b and h. And for proving this, let x be the unique solution of equation 1, so x satisfies the integral equation 6 as follows. And let's assume there is another solution of the perturbed equation with small perturbations in the harvesting term and production rate, which also satisfy the following integral equation, where these terms are the perturbed parameters. So in view of conditions 2, 10, and Green's function property 8, we arrive at this estimate, which shows that small variations or changes on parameters b and h led to small variations in the obtained solution. So the unique solution obtained of equation 1 depends continuously on parameters b and h. To validate the obtained findings, I will give two illustrative examples. So in the first one, let's consider the following iterative Lazotta-Wasilewska differential equation given by expression 11 in the set omega 1. So here, this term is the loss rate of red blood cells. This one is related to the production of red blood cells per unit time, and this is the harvesting function H. We choose a period of 19 days since the period can vary from few weeks up to few months. So in this example, we can easily see that the aforementioned conditions in the existence theorem are satisfied. The additional condition 10 is also satisfied. Moreover, if X is the unique solution of equation 11, and if there is a solution of the perturbed equation with the perturbed parameters, then we will arrive at this estimate, which shows that small changes on functions b and h led to small changes on the obtained solution. And since all the aforementioned conditions in theorem 2 and 3 are satisfied, then equation 11 in this case has a unique positive periodic solution in omega 1 that depends continuously on the harvesting term h and production rate b. In the second example, let's consider the same iterative Lasota-Wazuska differential equation 11 with the same period, but in this new set omega 2. So here we can easily verify that the conditions in theorem 1 are satisfied. However, the additional condition in theorem 2 is not fulfilled, which means that in this case, equation 11 admits at least one positive periodic solution in omega 2, which is not necessarily unique. In conclusion, let me briefly recap our main steps followed in establishing our main findings. So as I said at the beginning, our key task in this work is to prove the existence, uniqueness, and continuous dependence of positive periodic solution for our model. And for this aim, we constructed a Banach space of continuous and periodic functions and its subset, which helped us to control the iterative terms on one hand, and to easily apply our technique, which based on the Schroders and Banach fixed point theorems with Green's functions method on the other hand. The key step of our technique lies in converting our problem into an equivalent integral equation where the kernel is a Green's function. Next, with the help of some properties of the obtained Green's kernel, Ascoli-Arzela theorem, and under some assumptions, we succeeded in constructing an integral operator A, well-defined, continuous, compact, and maps the departure set omega into itself. Finally, we have concluded that all requirements of the Schroders fixed point theorem are satisfied. So if X is fixed point solution of the integral operator A, then X is solution of the integral equation, hence also of our problem. On the other side, besides the assumptions of the existence theorem and under an additional condition, the contraction mapping principle or Banach fixed point theorem ensures the existence of a unique fixed point solution of the integral operator A, which means that our problem has a unique positive periodic solution that depends continuously on parameters. Here are some of our main references. Thank you very much for your attention. Hello?
Thank you, Dr. Mava, for your talk. I hope, is anyone have any queries? I hope there are no queries. Thank you, everyone. Once again, thank you, Dr. Mava.
Thank
Let's
you.
move on to next talk. Next talk is by Dr. Ali Reza, National University of Technology in Pakistan. The title of the talk is Perspective of Biodiesel as Sustainable Alternative Fuels in the Transportation and Marine Sector. Dr. Ali, are you ready with your presentation?
Yes, I am ready. Can you hear me?
Yeah, I can hear you. Now I'm making you a presenter. Please click on your
Thank you.
screen. Yes. We cannot see your screen.
I think there is some problem. Let me share.
Okay.
Is it visible now?
Yeah, it's visible now. You can continue.
Okay. Thank you so much for giving me this opportunity to talk about the biodiesel. As you all can see that the topic of today is perspective of biodiesel as sustainable alternative fuels in the transportation and marine sector. My name is Ali Raza and I am senior lecturer in mechanical engineering department at National University of Technology Islamabad in Pakistan. This is my short biography. I am senior lecturer and I have authored a number of publications and book chapters. I am also serving as sub-reviewers of different international conferences and journals, and I am the coordinator of Departmental Quality Enhancement Cell, and I am expert in Washington Accord accreditation all procedures. My research interest includes the droplet evaporation, combustion, heat and mass transfer, fluid mechanics, biofuels, renewable energy, and internal combustion engines. So the today's presentation is linked with these three SDGs. Number 7, affordable clean energy. Number 9, industry innovation and infrastructure. And number 13, which is climate action. Okay,
Dr.
these
Ali,
are the agenda points, sir.
can you make it full screen?
I think it's full screen from my side. Let me see, please. Is it full screen now?
No, it's not.
Well, if from my side, it's full screen.
Okay, you can continue your presentation.
Thank you. Can you see my presentation?
Yeah.
Okay. These are the agenda points of my talk today. Introduction to biodiesel properties, environmental benefits, economical implications, technological advancements, biodiesel in marine sector, challenges and solutions, future generation biofuels, and then in the end, there are some references. Uh, Basically, biodiesel is a renewable fuel and also biodegradable, which we get from different organic materials. It's typically produced from different sources that are vegetable oils, animal fats, and other triglycerides, and we use them as a biofuel after a process known as transesterification. It is used as a substitute for different diesel fuels and gasoline in the vehicles. The term biodiesel is not new to us. It was introduced in the late 19th century. The modern biofuel industry began in the 1970s when the oil crisis began, and there was a need to think about the new alternative sources of fossil fuels. Uh, you may all know that the scientist Rudolf Diesel, who invented the diesel engine, originally he designed the engine
Dr.
to
Ali,
run on the yes.
sorry for the disturbance. Can you please unshare your screen and then again share your screen as the slides are not moving? Yeah, now it's moving.
Okay.
Okay, fine. Can you please enlarge your screen?
Mm,
Please give permission to the entire screen sharing.
I have given to the entire screen sharing also. Can I share it to you? Is it okay now?
Hello, Dr. Ali Reza. Sorry for the interruption.
Yes.
Yeah,
Yeah.
actually, your slides are not changing. Can you please unshare and share again?
Okay.
Okay. Once go to Meetings app, share the entire screen. Give permission to share entire screen.
Is it okay now? Can you
It's
see
okay. Can you?
the that
Now it
screen?
is perfect. Now it is perfect. You can continue your
Okay.
presentation now.
Thank you so much. There are different raw materials for the biodiesel production, which are vegetable oils, animal fats, used cooking oils, algae, jatropha, and other non-food crops. The production of biodiesel is very simple and involves a process called transesterification, which converts triglycerides into biofuel and other glycerine. At the end of procedure, we get two products. The first one is biofuel, and the second one is glycerine, which we separate in a chemical reaction. Here is a simple figure. We produce biomass, and then biomass is used for the biomass separation, and then biomass residues. At the end, we get the biofuel product, which is used in the engine, which contain marine biofuel blends and other B100 biofuel blends. There is a graph of biofuel production of equivalent per day per thousand barrel and the consumption. If you can see that the most of the production and the consumption is being done in the North America, and then Central America, then Europe, Asia Pacific, and then rest of the world. About 50% of the biofuel is being produced and consumed in the North America. It means America is the largest producer and consumer of the biofuel. Here are the different properties of biodiesels. To run a fuel in the internal combustion engine, we have some properties which are density, viscosity, flash point, cetane number, and etc. The biofuel contains almost properties equivalent to the other automotive diesel and the heavy fuels oil. Heavy fuel oil is used in the marine engine. Here are some environmental benefits of using biofuels. Biodiesel offers various environmental benefits when compared to the conventional fossil fuels. These benefits include the reduction in greenhouse gas emissions, lower particulate matter emissions, lower nitrogen emissions, biodegradability reduced, sulfur content, renewable resource, energy security, rural development reduced, toxic emissions, land use efficiency. The rural development involves the areas which have with low economic growth. They can cultivate the crops to produce biofuels and to maintain their livings. There are some certain economic implications which are relevant to the biofuel. The first one is job creation. The biodiesel industry creates jobs at various stages from feedstock production to the processing and distribution till the industry. The second one is energy security. Biodiesel production reduces dependence on the important fossil fuels, contributing to the energy security, and especially for the countries like Pakistan, we have a very heavy import oil bills. So we need to see the alternative fuel resources, especially biofuels. Price volatility, biofuel prices can be less volatile than petroleum the stability of feedstock prices. Economic value of feedstock use in the biofuel production can be significant for agriculture and relative industries. The next one is revenue generation. Biodiesel production generates revenue through the sale of fuel and byproducts like glycerine. Investment opportunities highlight investment opportunities in the biodiesel sector and how they compare traditional fossil fuel investment. Because nowadays we need more and more alternative fuel resources. Because in a certain research it is stated that by 2050 the all reservoirs of fossil fuel will deplete about 60 to 70%. Then we have to shift towards the alternative fuel resources. And the next one is technological advancements. The first one is feedstock development. Genetic engineering has been enabled to the development of biofuel specific feedstock crops which give you the more and more yields of biofuel. For example, researchers have genetically modified crops like algae and switchgrass to enhance their suitability for biofuel production. Enzymatic transesterification has been developed to replace the traditional chemical transesterification methods. Enzymatic reactions are more specific and can reduce energy consumption and waste production. Biorefineries. Integrated biorefineries. The concept of integrated biorefineries has emerged, allowing for the production of multiple bio-based products, which includes biofuels, chemicals, and materials from same feedstock. It means from a single feedstock, we can get multiple bio products. And then the second one is conversion of municipal solid waste into the biofuel. And the next one is waste reduction and sustainability. Algae cultivation for the biofuels can utilize wastewater and capture CO2, providing a sustainable and environmental friendly approach. And then the last one is advanced fuel blends. High octane biofuels. The development of high octane biofuels enables improved engine efficiency and performance, because in gasoline we need a high octane fuel for the complete combustion and burning of fuel to get a very high efficiency. Now, the main topic of today is biodiesel in marine sector. As you can see that in this graph, there is a role of biofuels as in marine fuel. You can see that there are different fuels which are ammonia, biofuels, methanol, LPG, LNG, and oil based. In the starting of 2025, the role of biofuel is very small, which is almost negligible. Now, if we continue moving forward from 2050 to 2025 to 2050, we can see that almost there is a 8 to 9% share of biofuels in the world energy resources, and biofuel holds significant promise in the marine sector as a sustainable alternative to the traditional marine fuels, because marine shipping is the most energy efficient form of freight transport till the day. It is the backbone of global trade, responsible for transporting 80% of the world's goods by volume and 70% of the global trade by value. Marine shipping sector heavily depends on the fossil fuels and is one of the largest consumers of petroleum fuels. The annual global marine fuel consumption is projected to be around 330 million metric tons, that is about 87 billion gallons, which is a pretty high number annually, which is higher than the world's yearly jet fuel consumption of 220 metric million, which is 1.4 billion barrels. It, it means that the fuel used in the marine sector is far more than the fuel used in the aerospace or airline industry. The overall demand for the marine fuel is expected to be double by 2030 due to the increase in the global trade. Here are some advantages of biofuel in the marine sector. The first one is, as we have already discussed, reduced emissions, improved air quality, fuel compatibility. And the next one is drop in compatibility. This is the most important factor and advantage of biofuel. The biofuel can be used as a drop-in replacement or blended with conventional diesel fuels in existing marine engines and infrastructure, minimizing the need for extensive modifications or investment. It means that there is no need to replace the existing engine of marine ships to use the biofuel. We can use the biofuel as it is in the engine with a little or small blending. The next one is biodegradability. Biodiesel is the biodegradable and less toxic than the traditional marine diesel, which can reduce the environmental impact in case of spills or leaks. Reduce engine wear. This is also an important parameter in terms of internal combustion engines. Biodiesel's lubricity properties can reduce engine wear and extend the lifespan of marine engines, potentially resulting in a long-term and cost-effective. Now, there are some challenges also linked with the use of biodiesel in the marine sector, which are feedstock availability. As we have discussed that the amount of fuel used in shipping industry is far more than the amount of fuel used in vehicles and aero industry. So we need a large amount of feedstock availability, and then we also need the high fuel quality standards. There are some problem of storage and handling. Like in the middle of sea, if we need the fuel, we have to be stored fuel in our ship or into the other ship. Cold weather performance, as shipping industry moves in very cold environments, so there are some performance issues. Then regulatory compliance, cost consideration, research and development. These are some issues which are linked with the biofuel in the marine sectors. Now, there are some advancement in the biodiesel in marine sector, and there is some ongoing research. The first one is NOAA Green Ship Initiative. It is a moment of happiness that the ship industries are using the complete biofuel, which is B100. The National Oceanic and Atmospheric Administration (NOAA) has pivoted the Great Lakes Environmental Research Laboratories small research vessel to reduce emissions by using B100 soybean biofuel. B100 means that it is 100% biofuel and there is no blending in it. Their entire marine diesel-powered 10-vessel fleet in the Great Lakes is powered by biodiesel produced from soybean oil. The conversion to biodiesel has reduced air pollution and operational cost to GLERL since implementation in 2000. The operational and maintenance costs are reported to have been reduced by 20 to 40%, which is a handsome figure compared with the petroleum fuel due to improved engine performance and life, and the reduction of maintenance due to the cleaning of properties of biodiesel. And the next is Hopper Dredger Alexander von Humboldt using 100% sustainable marine biofuel. Jandy Null Group reports that they have completed 2,000 sailing hours using 100% renewable biofuel oil on the vessel Alexander von Humboldt. They have partnered with Man Energy Solutions and Wood Fuels to successfully show that biofuel oil is ready to be used as a drop-in fuel to meet emission reduction targets. This project started in late 2019 and the vessel refueled several times during the first 9 months, which resulted in a reported 85% reduced CO2 emissions. The vessel operated on these biofuels during maintenance dredge work in Flemish seaports and the United Kingdom. After the successful performance of the Alexander von Humboldt, J&D Null Group has increased the use of biofuel in their fleet. And then next is Stina Bulk completes successful trial with ExxonMobil and Good Fuels Marine Biofuels. Stena Bulk is a tanker shipping company with a fleet of approximately 115 tankers. In April 2020, Stena Bulk and Good Fuels completed a 10-day sea trial of their sustainable marine biofuels. Good Fuels bunkered the vessel with biofuel oil at their location in Rotterdam. Stena Bulk 49646 dead weight ton Sozmax tanker C9 model was used to test the good fuels biofuel oil during its normal commercial cross-Atlantic operation, which reduced the greenhouse emission by 83% and reduced sulfur emissions to meet the IMO 2020 sulfur cap. Stena Bulk is now introducing low carbon shipping options for customers following the successful April operation test. A range of 20% to 100% biofuel will be offered, such as carbon offsetting program in which there will be about 5% carbon only in the emission from 100%. Here is a picture of C9 bottle which used biofuel. And then engine manufacturers. Caterpillar, a well-known company, has approved their engines to comply with the biodiesels that meet ASTM standard D6751 and EN 12241. Basically, B20 blends are accommodated in the most CAT diesel engines. Higher biodiesel blends can be used, but the OEM should be contacted before the use of B30 to B100 biodiesel engine. Cummins engines are allowed up to 5% biofuels on all engine models if the fuel meets all the standards. B20 biofuel blends can be used on limited engine models. Man diesels, large, medium speed 4-stroke marine engines have experience running on B100 biofuels, specifically those produced from feedstocks such as soybean, palm oil, sunflower oil, waste edible oil, and animal fat biofuel oils. Now, what are the future generation biofuels? The future of biofuels is underway with the development of next generation of biofuels derived from microbes and microalgae. These are considered to be viable alternative energy resources, devoid of the major drawbacks associated with first and second generation biofuels. While the next generation biofuels are gaining momentum in research and development and proving to be technologically feasible, more production processing techniques may be necessary to cost effectively produce biofuels in the bulk quantities required for the shipping industry. Because at the moment, there is almost 80% use of fossil fuel in the shipping industry. Next generation biofuels use microalgae produced into a fuel, and with algal biomass, there is no competition with agricultural food and feed production. There are several advantages of these higher generations over first or second generation feedstock, including efficiencies and optimum growth with minimal resources. Here are some conclusions of my talk. The number one is biodiesels are promising alternative fuels as compared to the fossil fuels. With the development and utilization of biodiesels, the dependency on the fossils can be reduced significantly. Drop in compatibility is most important aspect of biodiesel, which means we do not need to make any alteration in the engines. Greenhouse gas emissions are reduced by using the biodiesels. Biodiesels are cost effective as compared to the conventional fossils. Marine industry has started using biodiesels significantly. In the upcoming years, by 2050, biodiesel would share about 35% of the energy production for the whole world. And these are some references. Thank you so much for giving me opportunity on talking this prestigious forum.
Thank you, Dr. Ali, for your talk. Thank you for your presence as well. Does anyone have any
Thank you.
queries? I hope there are no queries.
Thank you so much, Clara.
Thank you. As per the schedule, let's take lunch break. We'll get back to you after 30 minutes from now. Kindly stay connected.
This conference will now be recorded.
You need to maximize your screen.
It is okay then? Uh, I think we have to start now.
Can you once exit and again share your screen?
Sure.
Can you once share your entire screen? Okay, now you can start your presentation.
Sure.
Okay.
Hello everyone. I'm Engineer Mohammad Aurangzeb. I'm a postgraduate research scholar in Department of Farm Machinery and Precision Engineering at Faculty of Agricultural Engineering and Technology, PMAS AAUR. Today's my presentation topic is mitigating drinking water scarcity in Pakistan, a comprehensive review of atmospheric water extraction as an urgent imperative. So what is atmospheric water extraction? Atmospheric water extraction is a process that uses different refrigeration techniques like vapor compression refrigeration, Peltier effect refrigeration, desiccant material refrigeration, and integrated hybrid refrigeration to extract water from the atmosphere present in the form of vapors by lowering the air temperature to its dew point that ultimately causes water to condense. Atmosphere is a massive renewable water resource containing approximately 12,900 billion tons of fresh water, 98% in vapors form, and the rest in a condensed state, clouds, and fog. Atmospheric water extraction related alternative technologies are the way forward for developing countries like Pakistan, where drinking water scarcity are the main concern in urban, rural, and especially in remote areas. Why it is important to mitigate drinking water scarcity in Pakistan? According to global assessments, Pakistan is ranked 14 among 17 regions facing significant water concerns, similar to arid and hot climates like Saudi Arabia. In Pakistan, more than 80% of the people experience unbelievably scarcity of drinking water for 1 month of each year. As a last option of water supply, Pakistan's underground water resources are also extensively depleted primarily to deliver water for irrigation purposes. If nothing changes by 2025, the entire Pakistan might experience scarcity of water. That is why it is very important to mitigate drinking water scarcity in Pakistan as an urgent imperative and provide alternative drinking water technologies that extract water from the atmosphere and provide safe drinking water. Drinking water quality status in Pakistan. According to MICS 2018 report, 63.8% of the home have access to clean water resources in urban regions. it is almost 60%, and in remote regions 66.6%. Additionally, 60% of rural families and 58.9% of urban families are said to use drinking water free of E. coli. When we used to say free of E. coli, it means it cannot contain sewage or animal waste contamination water. Mortality rate of water-related diseases and survival of the human race are both directly correlated with the drinking water quality. According to the Pakistan Council of Research in Water Resources Drought National Water Quality Monitoring Report 2015 and 16, about 35% of Punjab's water resources are suitable for drinking, free of physical attributes from bacteria and chemical toxins like TDC, hardness, turbidity, nitrates, iron, and fluoride, etc. Drinking water that managed safely.
Dr. Aurangzeb, sorry for the interruption. Your slides are not moving. Can you unshare and again share your screen?
Okay, okay, I'm good.
Can you move your slides?
Okay, okay, I'm doing.
Okay.
It is going now.
No, it's not
It
moving. Yeah,
it's moving. Okay then.
yeah.
So let's start.
Okay, okay,
Uh,
you can continue.
Hello everyone. I am Engineer Mohammad Aurangzeb, postgraduate research scholar in Department of Farm Machinery and Precision Engineering at the Faculty of Agricultural Engineering and Technology (PMAS AAUR). Today's my presentation topic is mitigating drinking water scarcity in Pakistan, a comprehensive review of atmospheric water extraction as an urgent imperative. So, what is atmospheric water extraction? Atmospheric water extraction is a process that uses different refrigeration techniques like vapor compression refrigeration, Peltier effect refrigeration, desiccant material refrigeration, and integrated hybrid refrigeration to extract water from the atmosphere present in the form of vapors by lowering the air temperature to its dew point that causes water to condense. Atmosphere is a massive renewable water resource containing approximately 12,900 billion tons of fresh water, 98% in vapor, and the rest in a condensed state, clouds, and fog. Feasible climatic conditions for atmospheric water extraction are humid, coastal, and semi-arid. When we say about the semi-arid, the average annual rainfall in semi-arid regions contain 250 to 500 mm, and in humid it is above 500 mm, and in arid region it is in the range of 150 to 250 mm per year. Atmospheric water extraction related alternative technologies are the way forward for developing countries like Pakistan, where drinking water scarcity are the main concern in urban, rural, and especially in remote areas. Why it is important to mitigate drinking water scarcity in Pakistan? According to global assessments, Pakistan is ranked 14 among 17 regions facing significant water concerns, similar to arid and hot climates like Saudi Arabia. In Pakistan, more than 80% of the people experience unbelievably scarcity of drinking water for 1 month of each year. As a last option of water supply, Pakistan's underground water resources are also extensively depleted, primarily to deliver water for irrigation purposes. If nothing has changed, by 2025 the entire Pakistan might experience scarcity of water. That is why it is very important to mitigate drinking water scarcity in Pakistan as an urgent imperative and provide alternative drinking water technologies that extracts water from the atmosphere and provide safe drinking water. Drinking water quality status in Pakistan. According to the multiple indicator cluster surveys MICR 2018, 63.8% of homes have access to clean water sources. In urban regions, it is 60%, and in the remote region, 66.6%. Additionally, 60% of rural families and 58.9% of urban families are said to use drinking water free of E. coli. When we say about free of E. coli, it means that it cannot contain sewage or animal waste contaminant water. Mortality rate of water-related disease and survival of the human race are both directly correlated with the drinking water quality. According to the Pakistan Council of Research in Water Resources Drought National Water Quality Monitoring Report 2015 and 16, about 35% of Punjab's water resources are suitable for drinking, free of physical attributes from bacteria and chemical toxins like iron, TDS, hardness, turbidity, nitrates, and fluoride, etc. Drinking water that managed safely. As you can see in the graph as well, sufficient quantities we have 91.4%. This is also from the report of MICS 2018, and 69.4% has water available inside their homes, and 63.8% has clean drinking water free of E. coli. In total, we can say that 43.7% of family members have access to clean on-site drinking water that is also readily available when they needed it. Climatic conditions of Pakistan for the atmospheric water extraction. In Pakistan's southern region, particularly around Makran coastline, average annual humidity is frequently around 80 to 90%. And when we talk about northern region, it is almost 65 to 80%, and in semi-arid climatic regions, the humidity is frequently around 50 to 70%, and also in arid climatic region, average annual humidity is less than 50%. The climatic conditions of different regions in Pakistan are favorable for the AWE as an alternative and sustainable way to provide drinking water. Atmospheric water extraction by using Peltier effect refrigeration method. It is one of the methods to give drinking water by using atmospheric water extraction. So when we talk about Peltier effect refrigeration method, Peltier device is a small flat semiconductor component. Basically, it is made of two type semiconductors. One is N-type and other is P-type. When current move from N-type to P-type due to the movement of electrons, temperature difference create across the device. One side of the Peltier device becomes cooler, obviously, while the other side becomes hotter. This is due to the transfer of heat energy from one side to another side. As the humid air passes over the cold side, due to the air's dew point temperature lower, it becomes condensed and collected in the form of droplets. Basically, it is a list of existing studies by the researchers on PER effect based atmospheric water extraction. We can say Khadim et al. He also uses Peltier effect refrigeration. Water production rate here is 10.1 milliliter per hour. Peltier system, it is mentioning his dimension. Relative humidity we can say 65% here, and temperature 31 degree centigrade, and power consumption rate is 70 watt. Atmospheric water extraction by using vapor compression refrigeration method. we can say here the compressor, refrigerant gas from the compressor in the form of vapors go into the condenser. Condenser is a phase change where gas convert into liquid, and from here capillary tube it controls the refrigerant flow and it goes into the evaporator. In evaporator, it is a unsaturated liquid form where 20% vapors and 80% liquid contain. So moist air from the electrostatic air filter when strikes into the coil of evaporator. At this point, the air's temperature goes down and lowers the air temperature to its dew point that causes water to condense, and then condensed water collect in the evaporator tank. From here ozone generator is used to remove any kind of contamination or bacteria, and then from the submersible pump and then different filtration like pre-carbon, post-carbon, UV and mineral filter, it ultimately ready for the drinking purpose. A list of existing studies by the researchers on VCR-based AWA. So, Patel et al. He also uses a refrigeration system, vapor compression refrigeration, and he says water production rate is 1.78 liter per hour. AW in different climatic regions. He uses vapor compression refrigeration. Temperature is 7 to 40 degrees centigrade. Relative humidity ranges between 27 to 95%. Energy consumption rate 0.75 kilowatt hour per liter of water production. Atmosphere water extraction by using desiccant material refrigeration method. The desiccant material like silica gel or zeolite is exposed to humid air. It acts like a sponge absorbing moisture from the air. As the desiccant absorbs moisture, it effectively dries the air, reducing its humidity. Once the desiccant has absorbed a significant amount of moisture, it needs to be recharged or regenerated. This is done by applying heat to the desiccant. Heating the desiccant causes it to release the moisture it absorbed earlier in the form of water vapor. The released water vapor is then cooled down, typically using a separate cooling system or refrigeration cycle. This cooling causes the water vapor to condense into liquid water droplets. The condensed water droplets are collected and stored for use and clean drinking water. And when we talk about DMR cycle, we simply describe in a graph we can use, and we can say that in the process A to B, first of all, dehumidification takes place. Like desiccant material, silica gel or zeolite, it absorbs the moisture in the air. When it absorbs moisture from the air, then it needs heat. When we apply heat, the moisture in the form of vapors goes out, and then we need regeneration. And the regeneration process, it also needs cooling, and the cooling causes the water vapors to condense into liquid water droplets. This is the process. A list of existing studies by the researchers on DMR for atmospheric water extraction. Atmospheric water extraction by using integrated hybrid refrigeration method. The system utilizes specifically designed PV glass panels. These panels serve as dual purpose. They generate electricity from sunlight like traditional solar panels, and they have a built-in layer of desiccant material. During the day, the PV glass panel converts sunlight into electricity, which can be used to power the atmospheric water generator system, or you can say atmospheric water extraction system. The desiccant layer on the PV glass has a high affinity for water molecule. As the humid air passes over the desiccant layer, it absorbs and holds onto the moisture, effectively drying the air. Once the desiccant has absorbed moisture, the PV glass is designed to cool down. often during the night or using a separate cooling system. This cooling causes the moisture to condense into liquid water droplets on the surface of the PV glass. The condensed water droplets are collected and stored for use as clean, drinkable water. This process of solar power generation, air intake, desiccant-based moisture absorption, cooling, and water condensation continues in a cyclic manner, allowing for continuous water generation from the atmosphere. A list of existing studies by the researchers on integrated hybrid refrigeration for atmospheric water extraction. These are the assessment of various refrigeration approaches for water extraction from humid air. So, the impact of environment, when we talk about vapor compression refrigeration, its impact is low. In Peltier effect refrigeration, also low. Desiccant material, low. Integrated hybrid refrigeration, low. And similarly, when we talk about suitability for the semi-arid and high humidity or coastal areas, the vapor compression refrigeration is high, and that is why it is very important for the Pakistani climates to talk about this refrigeration technology and adopt it. And we can say Peltier effect refrigeration, it performs moderate. Similarly, desiccant material, it is also high, and integrated hybrid, it is also high. But the most important thing is that water production rate in all those refrigeration technologies, the vapor compression refrigeration performs better. That's why it is important to talk about this technology and move forward for the sustainable growth. These are the conclusions. This review has been conducted to evaluate the working effectiveness of various refrigeration methods to provide alternative safe drinking water in Pakistan drinking water scarcity areas by extracting water from the humid ambient air. Introducing AW techniques in different environmental conditions of Pakistan is need of the hour to harvest renewable water resource from the atmosphere. Production of potable water from the AW focuses on the atmospheric parameters like relative humidity, temperature, saturation, vapor pressure, and dew point temperature. Peltier effect refrigeration and desiccant material refrigeration methods. Water production rates in the coastal and arid areas ranges from 96 milliliter per hour to 0.63 to 1 kg per day. Atmospheric water extraction by integrated hybrid refrigeration and vapor compression refrigeration methods. Water production rates in arid, desert, semi-arid, and coastal areas ranges from 2.12 liter per meter square per day to 25 to 30 liter per day drinking water. So these are the integrated and vapor compression refrigeration technologies are the main focus for the Pakistani climates to adopt this technology and move towards sustainable and productive growth of Pakistan. The effects on environment and the price of energy, construction and maintenance costs, suitability for arid, desert, semi-arid, high humidity or coastal areas. After analyzing the previous studies, reviews on these technologies and factors, the most suitable harvesting techniques that can be adopted in Pakistan are vapor compression refrigeration and integrated hybrid refrigeration atmospheric water extraction techniques that should perform well in different environmental conditions of Pakistan. Thank you. If you have any questions, please let me know then.
Thank you, Dr. Aurangzeb, for your presence and your presentation. Does anyone have any queries? I hope there are no queries. Let's move to next presentation. Next presentation is by Mr. Debjyoti Debnath. Rajkunwa College of Wagrul, India. Title is Theoretical Study on Transport Properties of Jonas Particle. Mr. Debjyoti Debnath, are you ready with your presentation?
Yeah, I am ready, madam.
Okay, now I'm making you the presenter. Please click on your screen.
Okay. Enter screen, no, ma'am?
Yeah.
So, is it visible, ma'am?
Yeah, but can you enlarge your screen? Yeah,
Yeah,
it's visible.
yeah.
You can continue.
So, thank you, madam, and the organizer to give the chance for this talk. I am Dr. Devajyoti Devnath. I am now currently assistant professor at Rajkunar College, Warghul, India. So today my topic is theoretical study on transport property of a genus particle. So, so first, I want to discuss my plan of presentation. So, I want to give some brief idea about the genus particle. What is genus particle and its different type of microswimmer, and the comparison with the diffusion property with this genus particle and the other particle, and some property like non-equilibrium phenomena, and the general application of this self-propelled particle. And then I will discuss my some recent work, the model dynamics of genus particle and genus particle as a cargo carrier, and then third one is the enhanced motility in a binary mixture. And then I discuss some important result of my thesis paper, and then the discussion of the and discussion and some near future work. So first I want to introduction what is genus particle. Now genus particle is a type of micrometer to nanometer size particle. Now why the name genus come? The genus come is from the Roman god genus who has two similar type of face. But here the genus particle is a typical type of particle which has some different type of face. For example, in the right hand side, the diagram is shown. One face is some other color and the some other face is other color. So this is just a symbolic picture. Actually, they have some different properties. For example, one face has some physical property, different type of. The other face will show some other type of physical property. And also they are differing chemical property also. For example, sorry, one face can absorb some light, but the other phase cannot absorb light. Okay, and also some other example is that suppose we have two type of particle. One is hydrophobic particle has a hydrophobic nature and a hydrophilic nature also. So if we put some normal particle, the phase of the particle can absorb randomly. The particle will be absorbed in the phase of the particle randomly. But if we put some genus particle, it has two type of phase. So one phase can absorb hydrophobic portion and the other is hydrophilic. So there is some phase separation can be occurred. And also a very important example is that the a genus particle suppose which is coated with platinum and the other phase is silica. So we know that in chemistry there is a very important reaction, the decomposition of hydrogen peroxide. Suppose the platinum phase, there is some hydrogen peroxide given, and it will decompose into water and the oxygen. So in the platinum phase, there is a loss of particle is present. So here is a concentration gradient is created, and due to this concentration gradient, the particle move into an opposite side. So the Venus particle has some self-propelled velocity in addition to its the Brownian velocity. This kinetic energy can be due to the concentration gradient or maybe the thermal gradient also. Second, here is some comparison of diffusion particle. Consider a normal particle, a normal Brownian particle, which can move in a zigzag way. The Brownian part, the diffusion constant is given by kBT. Kb is the Boltzmann constant, T is the temperature, divided by 6 pi eta R naught. 6 pi is constant, and eta is the viscosity constant of the solvent, and R naught is the spherical, we are considered as spherical type of particle. So R naught is the radius of this particle. So the diffusion constant of the normal Brownian particle is 0.03 micrometer square per second. But the corresponding to the genus particle, which has some additional velocity due to the self-propelled velocity, it has some extra term in addition to the Brownian particle term is proportional to his self-propelled velocity. And due to this, the genus particle in same environment, in same condition as the diffusion constant is 7.84 micrometer square per second, which is far greater than the normal Brownian particle. Here's some property of the genus particle. Suppose there is a present of an asymmetric channel. So if we keep some normal Brownian particle, it has an equal tendency go either to right side or the left side. That means here the probability of right side and left side is equal. So here the details balance is maintained. But if we put some Brownian particle in this asymmetric channel, it has a tendency to move either right side or left side. It depends upon the quality of the genus particle. So here the detail balance equation is not maintained. So this is an important, this is called ratcheting. That means the particle will move directionally, not equal direction. Okay, and some other property is called negative mobility. It is the negative mobility is that if we take an elliptical size genus particle and put into some rough channel. Okay, now if we apply force in left hand side, the particle will move into the opposite side. That means in right hand side or the vice versa. So these are some important non-equilibrium phenomena. Here the equilibrium phenomena is breakdown. Some important application of genus particle, that why you are so much interested about this genus particle. It has lots of application in biological science, robot science, in everywhere, in drug delivery, robotic microsurgery, cell biology, chemical industry, design and operation of micro robot, and separator quality. Here we have discussed some two property. Suppose we have to send some medicine to a cancer cell. If we can control the transport property of the genus particle, the one phase of the genus particle can be tagged with some proper medicine. And then if we can control the transport property, we can send the medicine to the appropriate cancer cell. And also suppose in a column, there is a two different type of particle is there. And we wish to separate the colloidal particle. Two type of colloidal particle. Now, if we put some genus particle, which has some peculiar property, one phase can absorb some particle, other phase cannot absorb. So, and also it has some self-propelled velocity. That means its velocity is greater than the normal colloidal particle. So, if we place this genus particle into the mixture of colloidal particle, it will absorb some particle and will move out. So, the two type of colloidal particle will be separated out. Now here are some discussion about my work about the modeling dynamics of genus particle. Previously, it is considered that genus particle has a spherical type. It is the most common model. But the fact is that the center of mass and the center of force is the same point. That's when in left hand side we have shown the conventional model where O is the center of mass and O is also the center of the force. But we have discussed a different type of model in which center of force and the center of mass are two different, because in case of normal motion of the particle where the Newtonian mechanism is applied, where if we apply a force to a particle, the force is act through the center of mass. Okay, but here the motion, the self-propelled velocity is not due to the Newtonian force. It is due to some concentration gradient or say temperature gradient. Due to this gradient, the force is acquired by this genus particle. So here the center of force or the center of mass may be two different type of particle, maybe two different points. So due to this model, we have find out some Langevin equation. Here the equation is given. X dot means the velocity in x position. V naught is the cell position, cell orbit velocity, and phi and psi are the angle is due to the coordinate, and psi is the extra angle due to the velocity and the center of mass, and d is correspond the diffusion constant, and zeta is the noise. Okay, and this is for also phi and psi. Here an extra equation is due to the fluctuation of psi, because the self-propelled velocity is not is fluctuated around the center of masses. So here an extra equation also this. This is a Langevin equation, and we have simulated this and we have found some result, and we will discuss the result of this model. Next is almost the same type of work, but this is also the based on our previous model. But here we have some particle is added. Suppose there is a normal Brownian particle which has no self-propelled velocity. So I have attached this normal Brownian particle with a genus particle, and we show that due to this attachment the particle can move with this cargo, and it has some three difference orientation called puller, in which it can pull the cargo, the passive particle, cargo or the passive particle, that's it, which has no self-propelled velocity, or it can act also pusher, and in stalled configuration there will be no movement. Okay, and the third work is that enhanced motility in binary mixture. This is a very important application of the genus particle. Here we have shown that suppose in a box there is a mixture of normal particle and the Brownian particle. Normal Brownian particle, that's when these are passive particle, and some genus particle. So genus particle has some active velocity. So here we have shown that a peculiar phenomena that from the velocity, from extra velocity of the active particle can transfer to the normal Brownian particle, and due to this, the diffusion of normal particle is also enhanced. So it is a very much interesting phenomena. So we will discuss this in details. And here we consider only the short range interaction between the particles, the short range interaction, and we have neglected any type of other interaction or long range interaction we have neglected here. So here the short range interaction means here we consider only the Lennard-Jones potential. So the Lennard-Jones potential is shown in equation 1, where VIG potential, epsilon is some interaction constant, sigma is the 2 times of radius, and Rij distance between the two particles. So this is the only short when the particles are very shorted, the attraction is due to the Lennard-Jones potential. Otherwise, there is no interaction. Now, the Langevin equation we have already discussed in our model, but here and some extra force is there that it is due to the that is due to the Lennard-Jones potential. The Lennard-Jones potential is absent in our first model. So that this is almost the same Langevin equation, but here an extra term, that is summation of Fijx. This is the summation of interaction due to the Lennard-Jones potential, and the others everything is same. And in case of in case of some overdamped condition where the mass is not so much, mass is can be neglected. So here the velocity distribution is cannot define. If mass is not important, the velocity distribution is cannot define. So in this case, we consider some effusion. That's when the particles are situated in a box and there is a single hole, and we find out the rate of effusion. And we see that here is also the rate of diffusion is increased if we increase the genus particle with the passive particle. Now here some main result. This is the result from our first diagram, where the diffusion constant is given by this cubo. Here we see that there are three type of region. In case of if we one type in y-axis we have diffusion constant, and in x-axis self-propelled velocity. If we increase self-propelled velocity, we can see that in case of lower value of self-propelled velocity, the diffusion constant is dependent upon the v square, and in moderate case it is almost independent of the self-propelled velocity, and in case of high value the self-propelled velocity is proportional to the self-propelled velocity almost proportional to diffusion constant. These three type of region can be explained through our proposed model. This cannot be explained by the conventional model. This is our second important result, where we say two type of self-propelled particle is there. Two type of particle there. One is passive and active, and we see that the eta is been here. The as eta is increases, that's mean the mixture the self-propelled genus particle is increases, and we see that as the eta is increases, the peak of the curve is moved to the higher velocity. That means when there is a more of genus particle, there will be more transfer of velocity to occur. And the efficient result is there. Here is almost same. We are here find out the diffusion constant and self-propelled velocity. Here is also same thing, but here the phase separation is occur due to the high value of self-propelled velocity. When the velocity is very high, where the velocity is high, in case of effusion box, the active particle form an other phase, and the passive particle may be other phase. So here we have to consider a self-propelled velocity up to a range, and up to a range, the effusion in case of effusion, the velocity distribution can occur. Now some application of my work, the motility transfer is very much important, and it can be the rate of motility of the weak sperm spell can be increased in presence of genus particle. And we also know that in chemical industry, to take place a reaction, the diffusion of the particle is important. According to collision theory, we need some collision between the particle. So in case of some case of the chemical reaction is inert due to the low diffusivity. So if we can put some genus particle, provided genus particle cannot will not take part in reaction. So here the velocity can be transferred to the low diffusive particle. And we are consider here only mainly Gaussian diffusion, but also there are in some work of mine there is non-Gaussian diffusion is also there, and which is very much important for the cell biology and microfluidic devices. And the conclusion is that the center of mass and center of force is the not same. These are the two different points, and we propose a model where the center of mass and the center of velocity are two different, and we show that the diffusion constant undergo transition from a coordinate to linear on self-propulsion speed, and diffusion of genus particle is very sensitive to the model parameter. And near future work is expected outcome is that the genus particle can be studied in different type of confinement. That means we are taking some sinusoidal curve. We can take the different type of sinusoidal curve in presence of some obstacle, which will helpful to find out some application in biological work also. And study of diffusion genus particle will very much helpful for designing that device which genus particle can be separated according to their mass and self-propelled velocity. And also this our work is the basis of the theoretical basis of the artificial chemotaxis movement. And this study will be very important to design some nanomechanical devices. Thank you. Hello.
Thank you. Thank you, Debjot Debnath, for your presentation. Does anyone have any
Hello.
queries?
Your sound is not coming properly.
I hope there are no queries.
Is there any question? Hello.
Hello. Am I audible to you?
Hello.
Hello.
Hello, ma'am. I am not able to share my slides. Actually,
Yeah.
sharing is not working to your side.
Are you ready with your presentation?
Yeah, I'm ready for presentation, but I'm unable to share my
Okay, okay.
slides.
Now I'm making you the presenter. Kindly click on your screen.
Yeah, now it's working.
Can you share your full screen?
Is it visible?
Yeah,
Slides
it's
are visible
visible.
on this
But
screen?
yeah, your slides are visible. But can you make your full screen?
Oh, okay.
Yeah, now you can continue.
Good evening, everyone. Myself is Dr. Shivani Dhal. I'm working as assistant professor in DB College, India. Today, I'm going to present my work, that is synthesis and structural properties of copper nanoparticles. Also, I am showing the process of synthesis of copper and CNT composite. Nowadays, people are working on copper CNT composite because copper wire is replacing in future. It can be replaced by the copper CNT wires because copper CNT based wires has good tensile strength and it can be stand in any weather conditions. So people are working on these wires. In this content, I'm showing to introduce the CNTs and how we disperse the CNTs in aqueous solutions. Then I will discuss how we synthesize the copper particles and copper CNT composite, and then I will discuss the structural studies, how copper affect the CNTs uh, properties, and then we discuss the joining of broken carbon nanomaterials using the EBID techniques, and then conclusions. As we know, CNTs is a remarkable material which has a good electrical, chemical, and physical properties, and it is a promising materials that is used in interconnected and sensing areas because of their high thermal properties and chemical reactivity. It is a stable materials in chemical reactions. Also, it has a high current carrying density. So this material, because of these properties, CNT is nowadays using as a prominent materials in the electrical as well as in chemicals area. As we know, the structure of the CNTs, there are three types of CNT depend on their tubular structures. CNT is nothing, it just rolling of graphene layers in different structures. Here we are showing there are three types of the structures. It depends upon the rolling of the graphene sheet. One is chiral, zigzag, and armchairs. As we know, CNT is used in many applications such as the wire interconnections, 3D wiring, transistors, flat panel displays, nanoconnectors, nanosensors, and nowadays it is used as a layer, conductive layer in the solar cell also. So, in this work, why we take the combination of CNT and coppers? As we said, CNT has a remarkable properties. It has a good electrical properties, and it can stand in high thermal conditions also. And this CNTs also not affected by the environmental conditions, so it is more stable than the copper. As we know, copper. When we place the copper in waters, it is corrosion affected, and the life of the copper is not good in different weather conditions. So people are looking for the CNTs and copper-based wire with the similar electrical conductivity and ampicities. Also, CNT is a very alternative, very light in weight that's compared to the coppers. That's why it is again a efficient materials in a future for electrical wires. Also, we have synthesized the CNT copper composite, and we find that there is a uniform decoration of copper and a particle CNT is possible. So this work has again find potential applications in future electronics. Also, these materials also as we as know CNT has a high flexibility. So, from the flexibility point of view, CNT copper composite again is a permanent materials in electrical wires. So we start with the dispersion of the CNTs in water. As we know, CNT has poor dispersion stability in water. So for achieving a good dispersion stability, we have to functionalize the CNT, and then we get their good dispersion even in water. So in my work, I have also start with the fluffy carbon powders, and then we have functionalized these CNTs into acid, that is a ratio, that is S2SO4 and HNO3, that is a piranha solutions. And we found that when we functionalize the CNT in the acid, the dispersion stability, this one is showing the dispersions of the CNT, this one is pristine CNTs. After the functionalizations, the CNT has a good dispersion stability even in water also. This is a semi-maze that shows that good dispersion of the CNT. There is no aggregations of the CNTs. For the synthesis of copper CNT composite, we have start with the pristine CNT, and then we have functionalized CNTs by attaching the hydroxyl and carboxyl group on that. And these functional groups help in anchoring seed for the copper nanoparticles, and this is like a structures, as we get a uniform decoration of copper nanoparticles, that is spherical copper nanoparticles on the CNTs uh, by on the surface of the functional groups. These are the SEM images as shown as a figure. These are the piston functional CNT without the attachment of the copper nanoparticles. But when we attach the copper nanoparticles, we get a spherical shape of copper nanoparticles, and they are very uniformly. There is no accumulation of the copper nanoparticles. So it is confirmed that the attachment of the copper nanoparticle on the CNTs. For the depositions, we have used the electrode deposition route. That is very easy to control in the synthesis process. By controlling the voltage and current, we can control the shape of the particles also, as well as size also. And this one is a comparison data of the Raman studies, as we show that functional CNTs has two bands, that is a D and G band. D indicate the disorder, or we can say that the presence of functional groups on the CNTs, and G band, that is a graphitic band, also confirm the graphitic order of the CNT. But when we attach the copper nanoparticles on the CNT, we found that the intensity of the D and G band is increased proportionally. uh, Also two bands, that is a G dash band and the higher order band is also Pierce. They also confirm the attachment of the copper nanoparticles on the CNT, or we can say that there is a structural change on a CNT when we deposit in a copper. These changes are in a positive way. G dash, the appearance of the G dash band indicate the increment in the electrical property of the CNT by due to attachment of the copper nanoparticles. And G's also can indicate that when we attach a copper nanoparticle, the CNT structure is more graphitic. In some cases, when we attach any nanoparticle on the CNT, the structures become rupture. But in this case, we found that by the Raman, the structure is more graphitic by the attachment of the copper nanoparticles. So we can say that there is no structures harmful structures dislocations in after attachment of these copper nanoparticles. So these are the electrical property of the CNT composites. Uh, This is the electrical conductivity that is taken from the paper that was published in Nature 2022. This is shows that the current density of the copper, that is black for copper and blue for gold, and this red one indicate the conductivity for the CNT copper nanoparticles. We found that when we take CNT copper, the amplicity and the current density is almost same as the copper and gold. So from this work we can say that by the combination of C and T copper we get the electrical conductivity equal to the copper wires. But with the CNT copper composite we get many other advantages like thermal stability is good, like other is it can stay in any environment. Also it is more flexible as compared to copper wires and more lighter in weight. This is an R case in which we shows that the conductivity of red is indicated for the CNT copper and copper the जो temperature behavior है. With increasing the temperature we get the result is similar like to the copper. It is also form as we increase the temperature the conductivity is going to down. That means it is showing a metallical behavior. So both copper and copper CNT both showing the metallical behavior. So in this work we have optimized and we found that when we attach the copper nanoparticle on the CNTs, we get similar behavior as a conductor metallic behavior as we're showing the temperature, negative temperature coefficient graph. Also we see that there is a improvement in the structure of the CNT when we attach the copper nanoparticles. Many companies in Singapore is working on this area for getting a good quality of the CNT copper wires. My another focus is the separation of individual CNTs from the gold pad. In this work, I am showing you how we can separate a single CNT that is suspended on the gold pad from the bunch of the CNT. So in this work, we have started with the silicon wafer, and then we have deposited silicon oxide, and then deposited a gold layer. And by using the photolithography, we get a gold pattern on which we have finally deposited deposited a single CNT that is hanging between the two pads. So this is basically this black lines indicate the channel whose channel length is 3 micrometers, and this gold contact is showing is the pad size that is around 100 micrometer. These are the optical images of the device. This is the optical image and this is the image optical image after the lift off process. So these are the channel that I'm discussed in previous slide. This is the 3 micrometers and this is a suspended CNT. We have probing the two probes on these pads. We found that the electrical conductivity of the single CNT that is around 300 micrometer. After that, we have deposited metallic contact, that is a metal PT, by using the EBI detector, that is electron beam induced depositions, and we found that when we deposit the nano contact on the end of the CNTs, the electrical conductivity is increased significantly. Before it was 300, and after that it is was 400 micrometers. So these are the different devices we have used in experiment. We found that after at each deposition, the electrical conductivity increased significantly, and so from this work we can say that we can change the electrical property of the single CNTs by deposition of the metal contact. It can be tungsten, it can be gold, it can be copper, it can be other metal which are available. So from this work we can say we can increase the electrical conductivity of the single CNT by deposition of the contact pads. During this work, we found that after giving a high sweep voltage, there is a broken of the CNTs, and the IV curve convert into the noise. So after that, we have recorded their SAM images, and we found that our CNT is broken in between the channel. So we have used same EBRD technique for the joining of the materials. Here we have used the tungsten metal, but we do the same work with the PT metal also. So when we deposit this tungsten on the broken area, we found that the noise spectra is converted into the linear curve. So from this work we can say that we can use EBRD technique for the joining of nanomaterials, but in my work we have used for the carbon nanotubes. But from this work we can say that we can do the nano welding of materials, nanomaterials key at a nanoscale by using the EVA techniques, and we confirm this from mechanical as well as electrical joining. This work is also repeated for the many devices. We get some result. Many noise convert into the linear from the, so in my work EBRD techniques work for the joining of the nanotubes. So in conclude, we can say that we have investigated the simple synthesis route, that is electrode deposition route for the deposition of CNT coppers, and this route is synthesis route is effective for my work with the structural as well as electrical properties improved step by step. Also, we found that the e-belt technique is a very good technique for the joining of the electric joining by the point of the electrical and by the electrical point of view. This is a good technique for joining the materials. Also we found that EBL technique is one of the best technique for increasing the electrical property of nanomaterials at the nanoscale level. uh, Thank you. I'm happy to give the answer of the questions.
Thank you, Dr. Shivani, for your presence and presentation. Does anyone have any queries? I hope there are no queries. Let's move on to next presentation.
Thank you.
Next presentation is by Neeraj Kumari, KR Mangalam University, India. The title of the talk is Impact of single and bimetal doping on structural and optical properties of copper oxide nanoparticles. Dr. Neeraj Kumari, are you ready with your presentation?
Yeah, ma'am, I'm here.
Yeah, now I'm making you the presenter. Please click on your screen.
Is my screen visible?
Yeah, it's visible. Can you
Okay.
enlarge your screen full? Yeah, it's visible. You can continue.
So, good evening to one and all being present here in this conference. And this is Dr. Neeraj Kumari, Assistant Professor, School of Basic and Applied Sciences, KR Mangalam University, India. So, before starting my presentation, first of all, I would like to say thank you to the organizing team to give me this opportunity so that I could present my work on this platform. The topic for my presentation is the impact of single and bimetal doping on the structural and optical properties of the copper oxide nanoparticles. So, if I talk about the nanoparticles, everyone aware that nanoparticles, those particles whose size is in between the range of 1 to 100 nanometer, and these are the solid colloidal particles. If you can see here that the range of the nanoparticles, that is between 10 to 100 nanometer, and if you talk about the atom, that is 1 angstrom. If you talk about the molecule, that is 1 nanometer. DNA, they are 10 nanometer. Viruses, they are 100 nanometers, and so on. So we can say here that nanoparticles mainly consist of micromolecular materials where the active ingredients is dissolved. There are different type of the nanoparticles, like depending on the origin. There are two type of the nanoparticles, that is natural and synthetic. Based on the dimension, there are four type of the nanoparticles: 0 dimension, 1 dimension, 2 dimension, 3 dimension, and on the depending on the structural configuration, There are four types of the nanoparticles, that is carbon based, dendrimer, composite, and metal based. If I talk about the metal based nanoparticles, again there are different type of the metal based nanoparticles, like metal oxide, we can say here, copper oxide, tin oxide, zinc oxide, cadmium oxide. There are different type of the metal oxide nanoparticles, and here we are going to discuss about the copper oxide nanoparticles. Now there are different synthesis methods through which we can synthesize these metal oxide nanoparticles, like sol gel method or like a co-precipitation method, which generally we include in the top down and the bottom up approach. So here we used a co-precipitation method, and for the synthesis of the copper oxide nanoparticles, generally we use two type of the salts, that is copper chloride and copper nitrate, whose concentration we took here zero point 0.5 molar, and both of these solutions were mixed in equal amount and on the stirring for the kept on the stirrer for 15 minutes. After that, NaOH was added drop by drop to these solutions, until we get the black precipitate, and this black precipitate obtained around pH 10. Why we are adding NaOH? Because most probably the precipitate generally occurs in the this basic alkaline medium. So after getting the precipitate, the washing of copper oxide nanoparticles was done using the distilled water and ethanol, and followed by the filtration, and uh, these nanoparticles were dried in oven at 80 degrees Celsius, followed by the calcination around 600 degrees Celsius for 2 hours, because if there is any moisture or any impurity that can be present in the synthesized nanoparticles, they could be removed through the calcination process. Now, if we talk about the single metal dopings, the starting procedure remains same, that equal amount of the copper salt with equal concentration, with the same concentration is taken, and after that there are different concentration of the doping metal we used here, that is 1%, 3%, and 5%. So after doping, after addition of this dopant into the base, again we kept the solution for the stirring, followed by the addition of the NaOH, so that black PPT again obtained at pH 10, and these nanoparticles undergo washing using the distilled water and ethanol, and then filtration and dried, and then the calcination, same procedure. And if I talk about the tungsten doped copper oxide nanoparticles, instead of cerium salt, we are taking here tungsten salt, that is sodium tungstate we took here, and rest of the procedure remained same. Next is the synthesis of the bimetal doped copper oxide nanoparticles, and here if we see, generally we used here for the bimetal 5% of the tungsten as well as the cerium. Why we used 5%? Because at 5% we can say here that best result we obtained here, so that's why we choose 5% of the tungsten and the cerium, and rest of the procedure remains same. So first of all, if we talk about the impact of the single and bimetal doping on the structural and optical properties of copper oxide nanoparticles. So first of all, let's discuss about the impact of the cerium on the optical properties of the synthesized copper oxide nanoparticles, and these optical properties generally determined using the UV visible spectroscopy. So here you can see that for the undoped copper oxide nanoparticles, maximum wavelength was found around 332 nanometer, and the band gap that is calculated by the TOC equation means half alpha h nu is equal to h nu minus Eg. So this band gap, that is the 2.3 electrovolt. So here we are calculating the direct band gap. Now on doping on the cerium in the copper oxide nanoparticle, if I say here that 1% doping of the cerium in copper oxide nanoparticles, the wavelength, there is blue shift in the wavelength, sorry, there is red shift in the wavelength we observed, and the band gap decreased. So generally decrease in band gap, we can say here that which might be due to the presence of the impurity state between the conduction band and the valence band. And if we increase the concentration of the cerium in copper oxide nanoparticles like 3% and 5%, blue shift in the wavelength was observed, that is 329 nanometer and 325, and band gap increase, because the band gap value that is inversely proportional to the wavelength, means if the wavelength is decreasing, band gap will increase. The increase in band gap, we can say here that that is due to the BM effect, that is Preston effect. And Preston effect, you can say here that when the all state which are close to the conduction band become populated, and this is because this populated state occur because of the shifting of the absorption as to the higher energy. Now, this is the impact of the tungsten on the optical properties of the copper oxide nanoparticle. And here, after doping of the tungsten, there is, you can say that again redshift, and on the redshifting, the band gap is decreasing. Again, we can say here that the decrease in band gap, that is due to the presence of the impurity state between the conduction band and the valence band. Now, sorry. Now, this is the impact of the cerium and tungsten doping on the optical properties of the copper oxide nanoparticles. And here, the maximum wavelength that is found around 380 nanometer in case of the bimetal doped copper oxide nanoparticle, and band gap that is found to be 1.43. Now, if we discuss about the impact of single and bimetal doping on the structural properties of the copper oxide nanoparticle, and these structural properties was determined using the XRD spectra. So if we see here, in case of the pristine copper oxide nanoparticles, the prominent peaks of copper oxide nanoparticles was found around 35.48, 38.72, and these HKL value generally calculated by using the JCPDS card number, JCPDS data, and these value matched with the JCPDS card number, that is 800076. And the average crystallized size of synthesized nanoparticles was calculated using the Saher's formula, which is we can say here that D is equal to zero point 0.9 lambda upon beta cos theta, where D is the crystallized size, we can say here. So at each angle we calculated the crystallized size by using FWHM value, and after that we took the average. So in case of the cerium doped copper oxide nanoparticles, the prominent peak of cerium that is found to be around 28.31 degree, and this is because of the presence of the cerium 4 positive, that is we can say here that oxidation of cerium oxide generally occurs here, and the crystallized size that decreases. So the crystallized size decrease, which might be due to the presence of the internal strain, or we can say here that generation of the internal strain to some extent, due to which crystallized size generally decreases. While in case of the tungsten doped copper oxide, the most prominent peak of tungsten, and that is because of the tungsten oxide WO3, that is found around 20.21 degree, and the crystallized size here increases. The increment in the crystallized size, we can say that because of the difference in the ionic radii, and because of this difference in ionic radii, the internal strain generally occurs, which we can say that results in the generation of the diffusion rate, and due to which the growth of the crystals generally occur. In case of the cerium and tungsten top copper oxide, means bimetal, again we can say that prominent peaks that around 19.21, that is because of presence of the tungsten oxide, and 28.75 shows the presence of the cerium in the bimetal doped copper oxide nanoparticles, and here the crystal size again decreases, that we can say because of the internal strain. Now, if I talk about the FE-SEM image of the copper oxide nanoparticles, so generally, you can say here that in case of the pristine copper oxide nanoparticles, the flake-like morphology generally occurs with a small agglomeration, and the this is EDX. This is the on the right hand side. This is the EDX of pristine copper oxide nanoparticles, which generally shows the presence of the copper and the oxygen in the synthesized nanoparticles. Now, if I talk about the size of the copper oxide nanoparticle, by using the J software, we calculate the size of the copper oxide nanoparticle, and that is found around 201 nanometer. Now, in case of the bimetal or cerium tungsten doped copper oxide nanoparticles, the particles generally found spherical in shape, and agglomeration was found more in case of the cerium tungsten doped copper oxide nanoparticles. And through the EDX data, we can say here that here, like copper, tungsten, cerium and tungsten peaks can be seen here. And because of this, generally indicated the presence of the cerium and tungsten or bimetal in case of the synthesized nanoparticles. Now, if we see here that the particle size of the in case of the bimetal copper oxide nanoparticle, that is found around 83 nanometer, means that that was generally decreased. Now, if I conclude my work, that so the doping of cerium and tungsten into copper oxide, this is not nickel oxide nanoparticle. This is only copper oxide nanoparticle. So, doping of cerium and tungsten into copper oxide nanoparticles generally shows the optical, structural, and we can say that morphological properties of copper oxide nanoparticles. And because of these modifications, we can say that some improvement in the optical absorption, catalytic activity, increased thermal stability. Because of improvement in these properties, these synthesized nanoparticles can be used for the different applications. And one of the most prominent application that now we are going to work on the photocatalytic degradation of the dyes by using these synthesized nanoparticles. So we can say here that bimetal doped copper oxide nanoparticles have reduced crystallized size and particle size, leads to the better catalytic properties. And so we can say here that finding of this study provide insight into the potential application of doped metal oxide nanoparticles. So these are some awards which I received, and these are my research articles. Now, thank you all for your kind attention, and if you have any query, you are most welcome.
Thank you, Dr. Neeraj Kumari, for your presence and presentation. Does anyone have any queries? I hope there are no queries. Let's move on to next presentation by Dr. Himani,
Thank
Central
you.
University of Rajasthan, India. Title: Identifying diagnostic protein markers in urine sample of malaria patients for non-invasive diagnosis. Now I'm making you the presenter. Are you ready with your presentation?
Yes, I am ready.
Kindly click on your screen.
This hello.
Dr. Himani? Dr. Himani, your slides are not visible. I think there is a technical issue from Dr. Himani. Let's move on to the next session. Next talk is by Dr. Jyoti Rajput, Lovely Professional University, India. Title of the talk, Efficient Electron Acceleration by Radially Polarized Hermite Gaussian Laser Beam in an Ion Channel. Dr. Jyoti Rajput, are you ready with your presentation? Okay, let me know when you are ready. Hello, Dr. Jyoti. Now I made you the presenter. Can you click on your screen? Yes. You please share full screen.
Okay, I hope it is visible.
Yeah, it's visible. Please share full screen.
Yeah, I have already shared the full screen. Is it visible as
Okay.
a full screen?
No, it's not visible as a full screen. It's showing slides. Yes.
Is it fine now?
No, it's showing slides.
Slides only.
Yeah.
Just wait.
Okay.
I hope it is fine now.
Yeah, it's fine now. You can continue.
Okay.
Thank you.
Okay, good evening, everyone. The topic of my talk today is efficient electron acceleration due to radially polarized Hermite-Kosach-Gaussian laser beam in an ion channel. So, myself, Dr. Jyoti Rajput, Associate Professor from Lovely Professional University, Punjab. So, basically, I will tell you about the brief introduction about the laser plasma interactions. And in this case, we are working with the terawatt lasers basically, which have the powers of which we have the intensities of 10 raised to power 19 to 21 watts per centimeter squares. So whenever this types of intense laser beam is allowed to pass through the plasma, the gases, it will interact with it and it will undergo the self-focusing effect. And these types of interactions are collectively called the laser plasma interactions. So what are the results of these types of interactions, which is very interesting? We can have the secondary beams of X-rays, gamma rays, nuclear radiations, and primarily we are choosing this kind of area to accelerate the electrons. So these are the key highlights for these types of interactions when the laser pulse is passing through the pre-plasma. We can take plasma also, and we can take the ion as a channel. So what is accelerator in this case? Accelerator, which is primarily an application for electron acceleration. It is a device which is used to produce a beam of charged particles which can be accelerated to very high velocities, provided some conditions are there. So these types of electrons, they have the nearly constant velocities or energies. They can retain their energies also, the higher energies. They can have the parallel trajectories and they can have the small beam cross section area. And to deliver these types of particles to a target where they scatter from the target constituents, this is employed to reveal the structure of the constituents, create new particles for study, or we can use these as to modify the character of the target, which can be tumor as well. And some daily life applications we can see for the particle accelerators are televisions in our house, the computers, monitors, the microwave ovens, oscilloscopes. In industry also, this kind of field has use in the food sterilization, electron microscopes, radiation treatment of materials, nuclear waste treatments, and medical applications like cancer therapy, radiology, sterilization of instruments, isotope productions. And this type of accelerators are used in the high energy physics, the light sources for the chemistry, biology, etc., and in the field of optics and the neutron sources.
So we can see that it can be used in the therapies also, where we can have some cancer treatments by this area, and imaging also. So why we are choosing plasma or ion as a medium, ion channel as a medium? Some drawbacks are there for the conventional large accelerators. These are primarily radio frequency accelerators, which have very less acceleration gradient. We can see that it is limited to 100 MeV per meters. The reason is the breakdown of the walls of the structure. And to get the higher energies, either we can use very lengthy accelerators in kilometers, which is very expensive. That is why we can choose plasma as a medium. We have large accelerator facilities as Stanford Linear Accelerator Center in US, the Large Hadron Collider at CERN, and International Linear Collider proposed electron-positron collider here. So how it accelerates the electrons? We can have the laser and the particle electron, and the strongest interaction of the electrons with the laser will occur if the velocity of electron will be equal to the phase velocity of the laser wave. So whenever this type of condition is satisfied, the resonance will take place. The resonance means the Doppler shifted frequency of the laser becomes equal to that of the velocity of the frequency of the electron. So basically the conditions which I was talking before is the laser will be able to excite the electron effectively only if it exerts a longitudinal force on the electron. So we have to set our laser accordingly, so that its phase velocity will be closer to the velocity of the accelerating electron. And in this way, the laser field will appear as a quasi-static to this electron, and the efficient energy transfer to the electron from the laser wave will take place. So these conditions are very, very important. And we can see that what is the benefit of choosing plasma as a medium. Number one, the plasma is not having any condition for the breakdown. So the major advantage is the plasma wave breaking, and it has the gradient 1,000 times higher or larger than the conventional radio frequency accelerators. So these types of accelerators are called the compact tabletop accelerators. So basically we have some we can say excitation mechanisms. These are plasma wave acceleration, self-modulated laser wake field acceleration, and laser wake field acceleration. And if we are choosing electron as a beam here, so it is a plasma wake field acceleration only. So we can have these important differences. If we choose plasma as a medium, there is no breakdown limit, and moreover the acceleration gradient, which is very high, we can see that it is 10 to 200 GeV per meters. So these are the benefits of using the ion channel or the plasma for accelerating the electrons. However, we have some challenges also, which are a future research area. How we can go for the phase matching condition of the electrons with the laser field. This is a challenge also, and how to produce a mono-energetic beam with the less energy spread, and moreover how to inject the electrons properly in the optimum phase. It is also a challenge, and the spreading of energy band, it is also a major challenge in this area. So in this case, I have considered Hermite Kosach Gaussian laser beam in the ion channel primarily. And why we have chosen this type of laser? This type of laser has a property to focus earlier. I mean to say that it has a very good self-focusing effect, and also it acquires very high order energy over a shorter periods of time. And moreover, the medium, which is ion channel, it generates the electric field that prevents the electron from escaping from the interaction zone. I mean to say that here in the interaction zone, the electron and the laser is interacting effectively, so that the resonance will take place. So these are some parameters which we have chosen. That is, we have focused on the intensity of laser A naught, laser spot size R naught, decentered parameter small b, the ion density Ni. So this type of effect we have seen to enhance the electron energy to giga electron volt. So it is a theoretical study here, which with the results are compared with the experimental results earlier, and we found our results very good. This paper has been accepted also in the laser physics letters. So in this case, we can see that the electric field of the laser is given as a combination of the radial and the transverse component, which is given as r cap er plus z cap ez. So how we can solve these electric fields? It is some analytical equation. For now, I am just showing the equations. So this is the radial component here, which is also called the transverse component in this case. It is given as r cap E naught Hs. We can see that the parameters are there. It is a spot size of laser R naught. It is a Hermite parameter. This is a Cossack-Gaussian wave factor, and the longitudinal component we can solve by using the equation, Maxwell equation in the vacuum. So we have already solved for the longitudinal component of the Hermite Cossack-Gaussian beam. This component is highly intense component, and it is mainly responsible to accelerate the electrons. This component is dominating component, and these are the parameters here, where small s is the Hermite functions order. It may be 1, 0, 2, like this, the lowest order, the first order, and the higher orders. And small b is a decentered parameter, which is actually associated with the laser beam width. So this type of equation we well know, I think. Force is equal to rate of change of momentum, which could be further written in terms of electric field and the magnetic field. This is called the Newton-Lorentz force equation. So we have used equation number 4. Here we have substituted the values of E, electric field of laser, the magnetic field of laser we have calculated, and the velocity components of the electron. And moreover, we have an extra field over there, which I stated before, the ion channel. So we have the electrostatic field for the ion channel also. This is the formula for the same. So a combination of the electric fields is mentioned over there. So this is our extra field due to the ion channel. So we can see that how the momentum will be changing in different directions for the electrons due to these types of fields. So we can have some softwares like MATLAB, Mathematica. We normalize our equations, and then we plot our graphs by using these types of softwares. So this is our plan for the work, the schematic diagram for the work. In this case, this is our radially polarized Hermite Cossack-Gaussian beam. It is the electrons are there in the plasma, in the ion. Here the electron injection is done with the electron gun, and this electron will be experiencing the field of the laser. Very strong field it is, and then after it will be moving in the spiral motion. So this is called the trajectory of the electron, and we can have the large amount of energy by this type of field. So eventually our electron energy will be in GeV, which will be saturating also after some time. So these are some plots I will be showing here. This plot is there. We can see that on the y-axis it is maximum energy of the electrons, which is gained by the laser, and this is the ion channel density, the density of the ions. So we can see that these are the normalized values, and we can also see these are the spot size of the laser. So as the spot size of the laser is increasing, what will happen? The energy of the electron is also enhancing. And moreover, if you increase the ion density, after the optimum value, it will try to decrease. So that we can see that why it is decreasing. We have some kinds of collisions also. right? So this energy is there and it will be reducing afterwards, but we can find the optimum value. And here, this is the decentered parameter, this is the energy gain, again maximum energy gain. So it is also seen that with the increase in the decentered parameter, this is enhanced, and after a certain point we can be able to saturate it, retain it. So these are all optimized parameters which we have solved, and we have seen the values from the softwares, and we have compared these values with the experimental papers for the feasibility, and the results are exactly matching. We have a lot of research in this area these days. And this is our last graph. In this case, we have seen that if we are changing the intensity as well as the velocity of the electron, whatever the electron we are injecting, if we control that velocity of electron also, then we will be able to get the higher energetic electron beam. So these parameters are optimized parameters. So this present study is very useful in the field of the medical treatments. So this is the conclusion. This line is a highlighted line for our area. We can see that because of the early focusing effect of the Hermite cos.
Dr. Jyoti, sorry for the interruption. We cannot hear your voice.
Thank you for your attention.
Thank you for your presentation, Dr. Jyoti. Does anyone have any queries? I hope there are no queries. Let's move on to next presentation by Dr. Himani Tripathi, Central University of Rajasthan, India. Identifying diagnostic protein markers in urine samples of malaria patients for non-invasive diagnosis. Dr. Himani, are you ready with your presentation?
Yes, I'm here.
Okay, now I'm making you the presenter. Can you click on
Okay.
your screen? Dr. Himani?
Could you, yeah, could you do that once again?
Yeah, I have already made you the presenter.
Actually, it is not giving the option.
Can you once exit and then log in again?
Okay, sure. Hello?
Dr. Himani?
Yes, I can see the option now.
Okay.
Can you see my slide?
Yeah, I can see your screen.
It's in the slideshow mode. Can you see that?
Yeah, yeah, you can continue.
Okay. So myself, Emmanuel Tripathi, I am a PhD scholar at Central University of Rajasthan, India. And the title has already been mentioned, so I am going to be talking about non-invasive diagnosis of malaria using the urine samples of patients. A brief introduction about malaria, that it is an infectious disease which is caused by the protozoan Plasmodium, and there are 5 species which are known to cause malaria in human beings: Plasmodium falciparum, vivax, malariae, ovale, and naulicum. So, according to WHO, there were about 247 million cases of malaria in 2021 throughout the world. And in the life cycle of Plasmodium, the causative organism of malaria, there are two hosts, human being and the female Anopheles mosquito, which actually acts as a vector. So, when a female Anopheles mosquito takes a blood meal, it injects sporozoites into the human host. And these sporozoites then go on to infect the liver cells where they mature into schizons. These schizons rupture and release merozoites. So, this part of the cycle is known as exoerythrocytic schizogony. After this, these parasites undergo asexual multiplication in the erythrocytes, and the merozoites infect the erythrocytes, and ring stage trophozoites are formed. These ring stage parasites then mature into schizons and again rupture to release the merozoites. Some merozoites among these go on to differentiate into sexual erythrocytic stages, which are the gametocytes. These blood stages are actually responsible for the clinical manifestation of the disease. And further, the gametocytes, which are formed, are then ingested by the mosquitoes, and inside the mosquito stomach, they get the favorable environment, and both the gametocytes fuse and generate zygotes. So they are the macrogametocytes and microgametocytes, which then fuse to form zygotes, and the zygotes grow and become motile, and then are known as eukaryote. Eukaryotes invade the midgut wall, and then develop into oocysts. These oocysts rupture and release sporozoites, which then reach the mosquito's salivary glands, and the cycle continues. So, I will be talking about the diagnostic methods which are already available for malaria. They include microscopy, which is considered as the gold standard method for detection of malaria. Others include RDTs, rapid diagnostic tests, PCR, flow cytometry, and automated blood cell analyzers are also used at some places. I would like to highlight that all of these methods, which are currently being used, are based on invasive methods for drawing out the samples. Basically, they require blood. So, our proposal is a non-invasive method which would not be requiring blood samples, but would be using urine samples. So, the objectives of my study include proteomics analysis of urine, cloning of the selected proteins, purification and characterization of those selected proteins, and ELISA-based quantitative detection of proteins in the in vitro and in vivo assays. Already, some research is being carried out on certain non-invasive samples such as urine, saliva, and hair, and there have been reports of detection of DNA in all of these samples. Also, the antigens HRP2 and Plasmodium lactate dehydrogenase, which are already being used for RDTs, have also been detected in the urine samples.
And in case of Plasmodium vivax especially, the MSP10 DNA, which is merozoite surface protein 10 DNA, has also been detected in urine. So, as I have listed the objectives of my study, these objectives would ultimately help to develop a diagnostic method which is obviously non-invasive, which has better compliance in case of repeated sampling, and there won't be a requirement of skilled technicians. So the methodology includes collection of samples from patients infected with Plasmodium as well as from healthy individuals to be taken as control. The second would be proteomics analysis, for which the SGS page would be done, and the gel bands would be cut and digested with trypsin, which will further be analyzed using LC-MSMS analysis. After this, the cloning of selected proteins will be done using PCR method or gene synthesis, and then these cloned proteins would be purified using chromatographic techniques such as NINT affinity chromatography, ion exchange chromatography, and gel filtration chromatography, and then characterized, after which quantitative detection of the proteins will be done using ELISA. So the samples were collected from Jailen Hospital, Ajmer, and they were infected by Plasmodium vivax. The ethical clearance and consent was taken. Then the proteomics analysis was carried out. So for the first sample, we treated the sample by centrifugation and acetone precipitation, after which we ran the samples on SGS page, for which the results can be seen, and the control and infected gels were compared, and the bands which were not seen in control gel were sent for further trypsin digestion, in gel trypsin digestion, and LC-MSMS analysis. These are the results of LC-MSMS analysis. We found certain proteins which were not found earlier uh, of Plasmodium parasite in the urine samples of these patients. In the second sample, the initial approach was similar, but at the end, instead of gel, we went for the in solution trypsin digestion, and then LC-MSMS analysis was done. Again, we got the results for LC-MSMS analysis, and again we had Plasmodium proteins present. After which, for the third sample, the initial steps were same. Here, we did a short gel technique in which we ran the SDS page up to 1 centimeter distance only. And these are the results. For this, we sent the control bands as well as the infected bands for in-gel trypsin digestion and then LC-MSMS analysis. The results are here, and again we found the Plasmodium proteins. Then from the proteins found in the LC-MSMS analysis, we moved on to the next step, which is the cloning and characterization of selected proteins. So from the proteins found, we selected a few proteins on the basis of abundance, half-life, and dissimilarity with the human proteome. So 4 proteins were selected: Riffin, RNA binding protein, erythrocyte membrane protein 1, and Duffy binding like merozoite surface protein 2. Then I started cloning these proteins. For the DVL MSP2 protein, I went on for PCR cloning, but unfortunately, I did not get the desired bands. There were no positive results, which is why I found that maybe because the size of the protein is because the size of the gene is too high, I should go for the protein domains, and then I again designed new primers according to the domains present, which are important for my results. So I used MotifScan, Interpro, and NCBI conserved domain search to find out particular domains in my genes which were lengthy, and then I designed the primers according to those. After now I am cloning those domain, and Other than that, for one of the proteins for which we found reports in the previous literature also, we got that gene synthesized, and then I I took the synthesized gene and transformed it into the E. coli BL21 cell, and then this transformed uh, cells were then checked for protein expression, and the protein expression was induced using IPTG, and it was checked at 2 hours, 3 hours, and 4 hours time, for which we can see that the expression increased. First, we can see that the expression is being shown at 2 hours, which has increased at 3 hours and again increased at 4 hour time. After that, I went for the protein purification using NINT affinity chromatography, and the protein expressed was then purified. Here we can see that the induction is done, and we can see expression after the induction has been done, and we can see that the supernatant contains most of the protein, so we do not have the problem of insoluble protein in this technique. And further, we can see that in the illusion we can see the band of the protein. So I would like to conclude that there are some plasmodium proteins which have been found in the urine samples of infected patients, which is a positive sign for us, as they some of them might have diagnostic potential, which we are going to check soon. And right now we are at the stage of cloning and purification of these selected proteins, and then the final results might actually lead to the development of a new non-invasive diagnosis kit for malaria. These are the references, and I would like to thank my supervisor, Dr. Tarun Kumar Bhatt, and JLN Hospital Ajmer, and DST Inspire for my funding, and obviously the organizers of the third International Conference on Applied Science and Engineering. Thank you very much.
Thank you for your presentation, Dr. Himani. Does anyone
Thank
have
you.
any queries? I hope there are no queries. Let's move on to next presentation by Dr. Irina Markova, Instituto Mexicano del Petróleo, Mexico. Title: Detection of intervals containing subhorizontal fractures in carbonate rocks by using the Stoney wave parameters. Dr. Irina, are you ready with your presentation?
Good afternoon, I'm here.
Yeah, good afternoon. Now I'm making you the presenter. Please click on your screen.
Just one moment. Mhm.
Please share your PPT. We can see your screen. You can start your presentation.
Can you see it?
Сейчас, сейчас.
Can you see it?
Can you see my screen?
Yes, I can see your screen. Please open your presentation. Yes, you can start now.
Thank you.
Thank you.
The theme of my presentation is detection of intervals containing subhorizontal fractures in carbonate rocks by using the Stoney wave parameters. It is well known that most of the world's oil reserves are stored in carbonate reservoirs. Many carbonate rocks, reservoirs of oil and gas, besides of small primary pores, also contain secondary ones, wax and fractures. The data on the structure of the pore space is important for the quantification of oil and gas reservoirs and the evaluation of extraction viability of hydrocarbons. Acoustic logging data acquired in a borehole contain important information about the rock microstructure, and thus they are widely used in petrophysics. In the present work, we propose a method for detection of subhorizontal microfractures by using the parameters of the acoustic Stoney wave. The Stoney wave is a guided wave propagating along the boundary between the borehole and the rock. The velocity and the attenuation of such a wave depend on the sonic signal frequency, the velocity of the compressional wave in the borehole fluid, and the elastic properties of the rock and the acoustic logging tool. Let us consider a system. Acoustic logging tool, infinite borehole filled with a compressible fluid, and transversally isotropic elastic medium. A linear axisymmetric acoustic source is located on the axis of the symmetry of the borehole. The propagation of elastic waves in a fluid-filled borehole is described by the equation, where Phi-F is the displacement potential of the compressional wave in the borehole fluid, and C is the compressional wave velocity in the borehole fluid. The fluid displacement W satisfies the following equation. In the case of axisymmetric problem, the displacement potential is described by the following expression, where P0 is the emitted impulse amplitude, omega is the angular frequency, F and S are the space and frequency spectrums of the source respectively, I0 and K0 are the modified Bessel functions of the first and the second kinds, and X1 is the amplitude of the reflected wave. The wave equations for transversally isotropic media in cylindrical coordinates are where ρs is the density of the solid phase, ur and uz are the radial and tangential components of the displacement vector. The law of Hooke has the form where Cij are the components of the stiffness matrix and Eij are the components of the tensor deformations. We calculate the displacement vector u using the following decomposition in the frequency domain, where Phi-S and Psi-S are the scalar and vector potentials of the displacement. Phi-S corresponds to the compressional wave, elastic wave, and Psi-S corresponds to the shear wave. The coefficients are found from the boundary conditions at the borehole wall. The boundary conditions at the borehole wall for a fluid-filled borehole are based on the continuity of radial displacement, continuity of radial stress, and vanishing of tangential stress. At the boundary between the tool and the fluid, the continuity conditions of normal displacement and vanishing of tangential stress are fulfilled. The integrand of this in these equations has singularities, the poles and the branch points. The branch points correspond to the compressional and shear waves propagated in the rock along the borehole wall, and the poles correspond to the two types of gadget wave, the Stoney wave and the pseudo-relay waves. By using the expressions obtained for determination of the acoustic pressure field in a borehole, we have calculated synthetic waveforms. An example of calculations is presented in the figure. Calculations were performed for the following parameters. The two lengths of 2.5 meters, the central source frequency f of 12 kilohertz. For immediate impulse, we have used the following expression, where omega 0 is the central frequency of the acoustic source, delta is the attenuation coefficient, and P0 is the normalization constant. The waveform contains the following packets of the following waves: compressional wave, shear wave, compressional wave which propagates in the borehole fluid, the Stoney wave, and the pseudo-relay waves. The acoustic pressure field in a borehole is determined by both the elastic properties of the rock and the elastic properties of the acoustic logging tool. In this slide, the synthetic waveforms calculated for different elastic properties of a logging tool are presented. The curves from 1 to 6 correspond to the velocities, to the compressional wave velocities in the acoustic logging tool material of 1, 2, 3, 4, 5, 6 kilometers per second. We have obtained a solution of the dispersion equation for the following models: borehole rock and acoustic logging tool borehole rock. This figure illustrates the results of the solution of the dispersion equation for the determination of the Stoney wave velocity as a function of frequency, with and without considering the influence of the borehole acoustic logging tool body. Carbonate rocks are characterized by the presence of microfractures. The presence of systems of microfractures change the elastic moduli of a rock. To calculate the elastic moduli of a fractured rock, we have used one of the well-known methods of micromechanics, named the effective field method, which permits to determine the elastic moduli of the rock at the correct density function. This figure illustrates the phase velocity of the Stoney wave at the function of frequency. The solid line, dashed line, and dotted line correspond to horizontal correct densities of 0, 1, or 2, respectively. In this slide, the result of the synthetic waveform calculations for different leading frequencies of the acoustic source of 12 and 3 kilohertz are presented. The calculation results are shown for the models of an isotropic medium without fractures and anisotropic medium with horizontal microfractures. The calculations have shown that the presence of horizontal microfractures practically does not affect the Stoney wave velocity, but the effect of horizontal but the effect of horizontal microfractures is more significant for the shear wave velocity. The Stoney wave recorded in a borehole has sufficiently low frequency, about 1 kilohertz. Thus, we can use the low frequency approximation for the Stoney wave velocity calculation. For a transversally isotropic medium with the axis of symmetry coinciding with the axis of the borehole, the formula for the Stoney wave velocity determination is given by where F is the density of the fluid in the borehole, K asterisk is the effective elastic modulus obtained by the formula, by the following formula, where B is the elastic modulus of the fluid in the borehole, F is a constant, R borehole is the borehole radio, R tool is the longitudinal radio, M is the elastic modulus of the medium behind of the borehole. M tool is the elastic modulus of the acoustic logging tool material. And M in the open hole coincide with the elastic modulus C1212 of the rock. The velocity of shear wave registered in a borehole is determined by the elastic modulus C2323. The fact that the velocities of the shear wave and the Stoney wave depend on the different elastic shear moduli makes it possible to detect anisotropic rocks by measuring the velocities of these waves. The Stoney wave velocity depends not only on the elastic modulus of a rock, but also on the elastic modulus of a logging tool. To calculate the elastic modulus of a logging tool, we can use the measurement data in a medium with well-known elastic properties. For example, such a medium is an interval of the free pipe in a borehole. For free pipe, the value of the elastic modulus M is described by the following expression, where h is the thickness of the casing pipe, d is the diameter of the borehole, e is the modulus of Young of the steel casing pipe. Using the equations for the Stoney wave velocity, we can calculate the elastic modulus of the logging tool. This slide presents algorithm for the detection of anisotropic intervals in a rock. First, we select an interval of the free casing pipe or rock with the known elastic properties. Then the problem of determining the elastic modulus of the acoustic tool material is solved by using the Stoney wave velocity data measured in this interval in the borehole. This is inverse problem. Then, using the measured shear wave velocity data, the shear modulus of the rock is calculated by the formula. The Stoney wave velocity of the rock is determined with the elastic shear modulus obtained in the point 3 of this algorithm by the formula for determination of the Stoney wave of the velocity of the Stoney wave. Then we compare the Stoney wave velocity that we have calculated theoretically and the Stoney wave velocity measured in the borehole. And finally, the intervals which are characterized by a significant difference of 2 or 3% between the values of the two velocities are considered anisotropic. In carbonate formations, the principal cause of anisotropy is the presence of microcracks. The method of anisotropic intervals detection that we have proposed was validated on the synthetic data and real acoustic logging data acquired in reservoirs of Mexico. This figure illustrates an example of application of the method of detection of fractured anisotropic intervals by a comparison of the theoretically calculated Stoney wave transit time with the Stoney wave transit time obtained from the sonic log processing. Intervals with significant difference between the values of the Stoney wave transit time calculated green curve and the Stoney wave transit time measured in the borehole red curve are considered with significant difference between the two values of Stoney wave transit time are considered anisotropic. Conclusions. In this work, we have presented a method of detection of intervals containing subhorizontal fractures in carbonate rocks by using the Stoney wave parameters. This method is based on the determination of two different shear moduli obtained from the measurement of the velocities of two elastic waves, the shear wave and the Stoney wave. These moduli are calculated by processing the acoustic logging data of the shear and the Stoney wave packets. The developed method was validated for both synthetic waveforms and real data acquired from some reservoirs in Mexico. Thank you for your attention. Thank you very much.
Thank you, Dr. Arina, for your presentation. Does anyone have any queries? I hope there are no queries. Let's move on to next presentation.
Thank you
Yes,
very
Dr.
much.
Thank you. Let's move on to next presentation by Dr. Ana Cecilia Barban Almada, Universidad de Sonora, Mexico. Title: Design and construction of a device to determine thermal properties of construction systems. Dr. Anna, are you ready with your presentation?
Yes, I am.
Now I am making you the presenter. Please click on your screen.
This is NASA presentation. It's a poster.
Okay, you can continue.
Can you see?
Yeah, I can see your screen.
Okay. The thermal properties of construction materials are of great importance to determine the internal thermal behavior of buildings, especially in places where the regulation does not provide information in this regard. and there are not enough technical sheets of the materials produced in local markets, especially in developing countries. This causes that when it's required to carry out an analysis by simulation of calculation of the thermal balance of the building, average values taken from bibliography or from references related to local materials are used, which generates errors in the final result. The present work shows the design and construction method as well as the implementation of a measurement device to determine variables that allow calculating the resistance and thermal conductivity of wall-type construction elements. The system consists of a full-scale test cabinet, which is subject to temperature differentials that can simulate the behavior of very cold or very hot climate based on the exchange with controlled temperature. The system works in isolation conditions, and when stabilized, it provides data in steady state that allow data collection and later calculation. The construction system can be solid or with cavities in such a way to the behavior of the air inside. The cavity is considered and that they are reflected in the results of the evaluation of the materials. Thank you. Can you hear me?
Sí, voy a hacer eso.
Can you hear me? Hello? Hello?
Hello?
Yes, I am here.
Yes, I am Paul Davila.
Excuse me?
I am Paul Davila. I am going to explain my topic or later. Sorry. Okay, I am trying to, to present. You can wait for me. What? 2 minutes, please. 2 minutes. Gracias, me están salvando para hacerles quedar bien. Gracias. Para hacerles quedar bien. Sí, sí. Ya. Yo guardé más. Ya le devuelvo. Gracias. Hola, gracias. Hola, vamos a hablar. Hola, ¿cómo estás? Ay, en París. Y me acaban de cambiar la hora. Préstame. Sí, es que hay. Está bien. Disculpa, gracias. 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 Pueden estar aquí. No, sí, no puede ir primero que tenga el sistema y de ahí separar el clip. Gracias. Ya lo digo. Ayúdenme con una cédula, por favor. Gracias. Gracias.
Okay. Can you listen me? Can you hear me? Can you hear me, please? Hello, can you hear me? I can start the presentation. Thank you. Sorry, thank you, Clara. Thank you all. I sorry for the difficulties to to have the presentation, but when I start, you can see my screen. Okay, I start. Clara, please, if you if you can hear me, please write in the chat. Thank you. I present. Okay, this is my presentation. I was talking about my topic. It's modeling and analysis of compression resorption heat pump system with a tropic mixture of CO2 acetone. Compression resorption heat pumps. It's a new research to an interesting option for increase the thermal level of waste heat. They use as a tropic measure, refrigerant and absorbent. In my particular case, it's a CO2 acetone. It's a good option for this application. Consider that CO2 is not toxic, it's available and is stable. The present work deals with the determination of the thermodynamic properties of CO2 or temperature, pressure, and concentration. Okay. Okay, you can hear me? Okay. About the way of the obtain the thermodynamics property of CO2 acetone mixture was through the method, the Penn-Robinson equation of state. In this slide, you can see in the right part the method of the interaction and comparison with the experimental data, and after calculate the binary parameter of this of the two phase between two phase, vapor phase and liquid phase. In this part, in the left part, you can see an equation that with three parameters, and in function with the parameters from the Penn-Robinson equation and the in function of temperature. This is the results, the binary interaction parameters that I obtained in different range of temperature. You can see the different range that I calculate these parameters to determine the properties thermodynamics. Also in my work, I determine the density of the mixture from the experimental data of Ramirez Ramos et al. And I obtain a correlation between the density of the experimental and the calculated. This expression is you can see, and the coefficients of correlations I present you. Also, I calculate the enthalpy and entropy from the ideal mixture of the enthalpy minus the deviation. Okay? The same way to the calculate of entropy of the mixture. We can see a vapor pressure diagram of the mass of the mixture of CO2 acetons in a range of temperature that 15 to 120 Celsius, and in a range pressure the 10 bars to 100 bars. In the finally slide, you can see the reported values in literature maximum deviations with literature. Also, I show you the diagram During diagram of the mixture. So in difference, the red lines represent the vapor phase, and the blue the liquid phase. Before the present the final results, I show you the assumptions for the simulation of the compressor resorption heat pump. I assume different conditions on the enter of the exit of the components. For example, vapor is saturated conditions and the compressor entrance. Solutions is a saturated conditions and the resolver outlet and the outlet on the separator is here. And two-phase solutions in the entrance of the dissolver and resolver are in equilibrium conditions. Okay. Also, the independent variables that I took, they are the outlet resolver temperature, the solver temperature, the mass fraction of CO2 of the outlet of the resolver, the vapor quality of the outlet of the resolver, because I assume that in this point it's a mixture in two phase. So finally, I present before the present the main results was necessary work in a cycle under standard operating conditions. For example, of the outlet of the dissolver, I fix a temperature of 30 Celsius, and the enter of the resolver is 70 grades, and the outlet of the resolver maybe 50 grades. With this cycle under standard conditions, with this case was the base for the present results. These are the principal results that are from the cycle simulation with the mixture CO2 acetone with different conditions, study parametric, in other words. For example, in the left, we can see pressure of the cycle work at 30 bar, right behind at 40 bar, and above and 50 bar. I prove with different temperatures at the enter of the server and obtain COP, or coefficient of operation of the cycle, maximum at 3. And the minimum is, of course, the work of heat pump, or also increase the want. This is the results of COP, and this is the results another parameter that was the flow rate radio. Flow rate radio, the maximum values that I found, that 7 with different conditions. That 7 with different conditions, and the enter in the temperature and the exit of the reservoir. Sorry. A conclusion about my work of this space was the modeling of the utilization of a novel mixture of CO2 acetone as a working fluid in this kind of heat pump. The highest values of the operation coefficient of compression resorption heat pump was 3 and was determined in these conditions. At the flow radio, the maximum values was 7.1 and was determined was under these conditions. On the other hand, the present model investigation reflected the parametric simulation, but in the next work, I work with the component in experimentally data, in experimentally bench, and I will present in the next, maybe the next year, I present the results about the component desolver. I decide because the heat exchanger conditions in actuality have limitation about the pressure. For this reason, my next work, I will present the results about the desolver, the behavior of the mixture of the desolver. Thank you so much for your time, for the passion, because the difficult to connect. And if you have questions, I attend you. Thank you.
Thank you, Dr. Paul, for your presentation. Does anyone have any queries? I hope there are no queries. Thank you, Dr. Paul.
A pleasure. Thank you, and sorry again for the difficult. Thank you.
Okay, fine. By this, we come to the end of day 1 webinar. I would like to thank all the attendees and participants of today's webinar. Hope you enjoyed the webinar and gained knowledge from this seminar. And I request you to attend the tomorrow's seminar too. If you have any queries, you can email me. Thank you.
Thank you all.
Thank you, everyone.
Thank you.